morning, everyone. Good morning. That's all we get today? Where's my gigabits? No gigabits today. Only 210 megabits today. Well, that's a good number of megabits. Let's see if anyone's actually alive in my stream. Let's finish off this energy drink, and then we can open up the sponsor drink of the day. Okay, we're finished with the energy drink. We'll place this in the trash in order to keep our workspace clean and tidy. And today's stream is brought to you by La Colombe Cold Brew. It's cold brew. It's black. It's unsweetened. It's a medium roast, and it's described as bold and rich. Now, something that I want you guys to realize about this coffee is that what's actually inside this can is only slightly correlated to what's on the label. Everybody assumes that the label, people just look at the label. Like, I was out yesterday and I saw a place that said, like, Bonehead Burgers, best burger ever. And for a minute, it bypasses your critical reasoning. It's like, wow, they must have good burgers. But then you realize that anybody can just write that. And that's just something you got to think about. Right? And this is why we need a humanities education to teach people. See, the reason that they corrupted the humanities and make you read bell hooks is because if people had a real humanities education, they would be less susceptible to advertising. So that is why the Marxists infiltrated the humanities departments of colleges, because it's not because the powers that be believe in Marxism. It's because if you actually had a humanities education, you would see advertising and you'd think critically about it. And then you would buy less stuff. And then the GDP would go down and China would win. And we can't let China win. So stop thinking critically, accept advertisement into your life. You do it already. Don't worry. This isn't probably even behavior you have to change, because you've been conditioned since birth to believe in advertising. Now, what were we going to say? Oh, yes. I also think we should take a minute today and realize how absolutely wonderful the world is. AI is great, women are great, everything's just great, man. And, if you don't see the greatness of life, well, that's a you problem, because life is great. God is great, that's right. Can't forget about God, the man upstairs who created all of this. And if you don't believe in God, what do you believe in? Where do you think we came from? Do you think we came from the Big Bang? That doesn't even make sense. That's like saying toast came from the Big Bang. No, toast was made in a factory by people with a toaster, obviously. It wasn't made by a Big Bang. And why do you think the world is any different from toast? I don't know why you would think that. Okay. The pizza. Oh, I love pizza. Oh, pizza's so good, guys. Oh, I love pizza. Yeah. But, don't be fat. Don't be fat. Like, there's no excuse for that. There's no excuse for that in today's world. Today's world is measured not by what you say yes to, but by what you say no to. How much self-control do you have? Are you going to be able to avoid the great wireheading? And if you are fat, the answer is probably not. You're going to end up wireheaded. You couldn't even say no to food. So there's that. George, you're not allowed to say things like that. Well, you know what? It's the current year. And, let's not make this political, because you were actually always allowed to say whatever you wanted. People can just choose to listen, and I hope you choose to listen to me. I hope you subscribe to my channel. I love having most of you here, and some of you I don't like, but that's just how things are. Not everybody's going to like you, and the sooner you learn that lesson, the sooner you're ready to open this La Colombe cold brew, who didn't actually sponsor me. But if they actually sponsored me, I don't know. Like, I'm hoping someday that a brand will reach out to sponsor me, but they understand that my endorsements will only be ironic. But then the brand is just okay with that, because the brand understands that irony is the only real truth today, except it's still irony, but it's also real truth, but only sometimes. Welcome to postmodernism. I hope you guys like it here. I hope we can all move past it. And you can never move past things by going back. You can only move past things by going forward. We never go back. We're never going to make America great again, but we might be able to make America great if we all figure out how to use more energy. And with that note, can we get ads? I wish it was Elon's administration. Oh, I wish it was Elon's administration. Yeah. No, I don't know. Let's not go into that. Let's not go into that. Let's just talk about how this isn't even going to matter, because all these people are going to be replaced by AI. And then, oh yes, going to Marrakesh. This came on the, this one. This came on this morning. Oh, the day of reckoning is coming faster than anyone here realizes. Oh, yeah. So that's, I used to talk about the day of reckoning so many years ago, and like, the day of reckoning is actually upon us. Oh, it's so wonderful. It's so wonderful. Am I just happy because I know other people are miserable? No, that would make me a terrible person. I think I'm just happy, but what if it's like what's the principle of equivalent exchange? What if it's like the principle of equivalent exchange? Oh, that would be awful. We did get the diffusion model to work last time. We had a good stream last time. It was a good stream. We got something to work. New people could follow it. All right. Do you really believe people's jobs will be massively replaced by AI? You are the reason we're going to subscriber-only chat. Congratulations. There will be no more talk of politics, because I read a YouTube comment that said that I should stick to coding and shouldn't go into politics. And the point of that comment is to have a chilling effect. The point of that comment is to make me reconsider. But in real postmodern, ironic fashion, we are going to just live by the comment. You know, the bean system. Yeah, okay, good. All right, let's make me smaller. And why does this chair make noise? This chair would be better if it didn't make noise. I feel like I need to get like lube or something. You know, let's like, get some grease. Let's grease the chair. Are you brushing your bats, guys? Okay, so yeah, we don't need that crap. Sudo rm mod AMD GPU. Let's take that out. And like here, so let's start with like some beautiful MNIST multi-GPU training. 50bug equals 1, so you guys can say, oh, we should, if we install that module, it will not poll, and it will be able to use interrupts, but otherwise it still works. Okay, so what is FSDP, and how do we use it? Is FSDP just a PyTorch thing? Why when I search for it, I get just PyTorch? So let's first talk about how that sharding works. So this is that example. You see we're going across 2 GPUs. We, that's sharding the test data, but you see we also shard the training data on axis 0. We put a copy of the model on all the GPUs. Oh, that's cool. Oh. Probably don't even need to make it shard there anymore, but still, that's cool. So I rewrote the multi stuff and got that merged last night. This is all O of 1. So we should be able to, if I run with viz equals 1, that's slow. Why is that taking so long? Oh, really? Oh, am I just not on the network? Huh. Hang on, I gotta check my network settings. Weird. So it says I have a self-assigned IP. I don't know. I unplugged and plugged it back in. Okay, now I have an IP. Okay, good. Let's see if we're not. Yeah, now we're talking. Yeah, that's a better speed. I don't know why that didn't come up. Okay, so yeah, Viz is now working. Okay, great. I was like, yeah, what do you mean? I'm on the network. So there we go. Cool. So you can see multi-map's probably interesting. Oh, these things are so massive. Here's the test one. Maybe that's more viewable. So here's the test data coming in. You see this multi, and what this multi does is it just shards along axis 0. Oh, look at all that! Look at all that ugliness that isn't getting merged. Oh, there's so much work to do here. There's so much work to do here. But then you can see we propagate the multi through those things. Multi's kind of like a concatenation operation between two. So like we shard the test data on axis 0, which means like you have a tensor. Tensor's got dimensions. Take axis 0, chop it in half, put half on each GPU. So that's what that does. And then the beautiful thing about this is like the backwards pass just works. You don't have to think about, in tinygrad, you don't have to think about like multiple processes. You just literally shard it across a bunch of devices, specify the axis you want to shard it on, and tinygrad does the rest. So a lot of tinygrad stuff is similar to JAX. Like we have these separate things that are composable, but JAX focuses on doing it on the function, and we focus on doing it on the tensor. So this means shard in place on axis 0, whereas like JAX will have you create a function and specify the sharding of the function. Just different ways to do it. I don't know. I much prefer to think about it this way. It's like more like imperative, but it still retains. I have a theory that the reason functional programming didn't take off is, like, I think functional programming overall is a superior paradigm. But the problem is a lot of the implementations of functional programming are not written by the kind of people who want to get stuff done. They're written by the kind of people who want to circle jerk about functors in a monad space. So tinygrad keeps a lot of the beauty of functional programming, but while still keeping the like imperative programmable nature. So when I mean like it keeps the beauty of functional programming, so these UOPs, which are what specifies this compute, so like this is the test roll out here, are entirely, they're immutable. It's all just state transformations on the UOPs. We're very careful about where we keep state. So you can see like here, this is the simplified tensor graph. So here you see we chop it to the two devices, and then this is after it's processed. So even though there's 10,000, you'll see that it's copied to both devices, and then we chop it based on device number down to 5,000. Now in reality, this view should be moving before the copy, and right now we're wasting compute on that, so somebody should fix that. But cool. We'll cast it to float. What is this? What's 800 that's being multiplied? Huh. Oh, I mean, maybe that's just the first. Yeah, wow. So that's the convolution there. Yeah, see that this stacks both the convolution and the device number. Oh, there's so much work to be done here. So that's the convolution. This is a bunch of convolution weights. This here is a 5 by 5 convolution. You can see the 5, 5 here, and they're both, so axis 6 and 7, 0, 1, 2, 3, 4, 5, 6, 7. See the reduction across 6 and 7 because it's a 5 by 5 convolution. Here we just get rid of all these ones. So we're left with a 24 by 24 image with 32 channels and a batch size of 5,000. Here it looks like we add a bias. That's a ReLU. We probably shouldn't write ReLU like that. I think max should just work. I don't know why ReLU is being written like that. Someone wants to fix that to be max, but that is a ReLU, right? Right, you compare it with 0, and then where that comparison is true, you pass through the thing. Otherwise, you put it 0. So here we're prepping for another 5 by 5 convolution. 5 by 5 convolution, blah, 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 blah. So this runs on both devices. You can see that these buffers exist on AMD and AMD1. What is this, like batch norm crap? Looks like batch norm crap. Some more convolutions. Actually, that one's not a convolution. I don't know what that is. Oh, it is a convolution. Wait, no. That? Oh, no, that's a max pool. That's a 2 by 2 max pool, right? Because we have 2, 2. We're maxing on 4 and 5. You can see that, like, axis 4 and 5 goes from 2s to 1s. Yeah. 3 by 3 convolution. We're also reducing across the channels axis here. So I guess that first convolution doesn't have any channels. But so the convolution has 32 input channels, 3 by 3 convolution, reduce, another jankily specified ReLU. Oh, someone needs to fix this. Yeah, there's a reason why we wrote it this way, but I hope that reason's gone. That transformation should at least be happening much later. That should not be in the tensor graph. That should just be a max in the tensor graph. That was an all reduce. That rendering is so much less nice. When you look at these renderings here, you can see that it's based on the device number. So whatever this is, wait, really? Yeah, there's so much to fix up here, right? Like that view needs to make its way over there. Well, I don't know, maybe it doesn't matter. No, it probably doesn't matter. Still. This could still be nicer, right? Because that's the view. So this is a bias. You can see the 0 strides there across the, so only the channels dimension has 1 stride. See the batch dimension and the width and height dimensions have 0 strides. Yeah, object-oriented programming overall was a like a failure. Oh, we also launched something yesterday. You guys can try it out. Stats.tinygrad.win. So this is all the performance stats from the tinygrad hosted CI. Oh, wow. We're getting panels. That's pretty nice. Values must be in ascending orders. Cool. Yeah, it'd be nice to put them all in panels like that. I think we need some organization. Oh, so nice. Yeah, stats.tinygrad.win. I did it through Cloudflare. I love Cloudflare. Cloudflare is like, you try to use like AWS for something and it's just upsetting. Like clouds are upsetting, but Cloudflare does deal with a lot of. I also like Tailscale. I'm pretty impressed by these. I mean, I know that like one of these days they're going to rug me. I actually don't think Cloudflare is going to rug me. Tailscale. Hang on, we gotta clean a piece of lint out of the keyboard. It's driving me crazy. The OCD is strong today. So what do we have here for lint cleaning? There's a pen. Is that gonna work? Hermias. No. Okay, we got to figure out how to get the lint out of the keyboard. Okay, this just has to happen. All right. And here's a paper. Here's some stickers. We got the lint out of the keyboard. Okay. Okay. Now we can continue. Okay, so let's look into what FSDP is and how we can shard FSDP better. We also maybe, do you guys want to go through like a simple training example of multi? I mean, this is a pretty complicated model. Here's the model here, right? Remember we were saying 5x5 convolutions, batch norm max pool, 3x3 convolutions, batch norm max pool. And we'll try to view it again and maybe it can work. But so right now what we're doing is we're sharding the weights to all the GPUs. And I think you have to do that no matter what. But then inside of here, Atom, we are creating these tensors on all the devices. And I think this is what you don't have to do. All right, so here's our implementation of Atom. I mean, it's called Lamb because you can just take Lamb and set, like Lamb is, you just add this, it's like the bounding factor for the learning rate. You can read the paper. But yeah, this is the whole optimizer. The optimizers are one of the prettiest parts of tinygrad. They're really nice. So like this is SGD, this is Atom. But yeah, we probably don't want to do this on all the devices. I think we can put it on less devices. Okay. Do we have to get the glasses out? We need the glasses for reading. I kind of think we need the glasses for reading. Now we can read. This is so bright. It's so bright. Can I like enable, like, is there like a dark mode? All right, we got to just stop with the OCD today. It's widely acknowledged that large models have the potential to deliver superior performance across a broad range of domains. I have an astigmatism, and it makes it hard to look at very bright things. I don't really understand it. It's not like terrible, but that's what my glasses fix. Maybe we should go get them. Should we go get the glasses? What do you guys think? chat. O3 in agent mode. What is this OpenAI Codex thing? It's like the year of agents or something. The men in black are coming. Yeah, it's hard when screens are bright to read them without the glasses. I think I actually even pay for this stupid ChatGPT Pro. It's also possible that the only reason I like the glasses... Oh, wow, no. It's like so much easier to see that kind of stuff. Otherwise, I get like... Meh. Fully sharded data parallel. There's also a paper called I think it was Deep Speed. Yeah, this stuff. Okay, so this is interesting here. What's K? Oh, the memory multiplier of optimizer states. Based on mixed precision training with the atom optimizer. Oh, that's interesting. So even if our model is in float 16, we're still using float 32 for M and V. Interesting. Do you have to do that? I mean, because that's going to be... Okay, so there's... So how do they get 12? I see 8. Those are tiny. How do they get 12? Yeah, there's online sites that let you invert the colors, I'm sure, but then I gotta like do that. Why does this not work? Hey, OpenAI, if someone from OpenAI is watching, why does this do this? Low communication volume, scale them. Okay. It's large models. Linear speed up, blah, 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 blah. Okay. Basic data parallelism does not reduce memory per device, and it runs out of memory. Yeah, model parallelism sucks. So we're doing data parallelism in this example, right? Because we're sharding the data. Here was where we shard the training data. We shard the data on X is 0, and we put a copy of the model on every GPU. Adam. Oh, okay. Master copy of the weights. I understand. Cool. Do I keep a master copy of the weights? I'm not sure I do. Why does data parallelism suck? I mean, all the reasons they're talking about here. Basic data parallelism does not reduce memory per device. Okay, model parallelism, blah, 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 blah. For large models, the majority of the memory is occupied by model states, which include the optimizer states. Residual states. Interesting. I actually think we don't do this in tinygrad. I mean, yeah, we don't do this. All right, because sure, I mean, yeah, we might run this in. Where's LR? Oh, we also do that. That stuff, that's all going to be in float 32. Well, we really have not thought this stuff through. But that's definitely going to cast it back to float 16. That's probably going to get casted here. Again, yeah, the LR is going to be float 16, but that is going to be float 32. So that's all going to become float 32, and then that's going to become float 32, and then that gets casted back. Partitioning of optimizer states, gradients, and parameters. Optimizer state partitioning. Okay, so how are they doing this? You can't do that with parameters. Let's think about what this is doing on multi. So this just exists on the multi device. It's probably like all reducing across those. Yeah, I don't know if we've given any serious thought to this at all. How much of our ML perf slowness is just due to nobody paying any attention to this kind of stuff? Don't care about that. All right, can you get to like how it works? No, I don't care about the related work. Okay. Typos in your paper. ith data parallel process only updates the optimizer states corresponding to the ith partition. So how are these things being partitioned? Deleted. Also, does the memory viewer work? We have a view memory graph now. All right, cool. Does this not work on the multi-buffers though? How come I don't see any multi-buffers in here? Oh, this code works. Yeah. Okay. We need to add this to the number of lines in tinygrad. This is crazy hard to read. I don't even understand how this works. Ah! So these are the kernels. How come when I view the memory graph, the device only includes, how come it says device equals AMD? This is also the, let's look at the training one. Where's the training one? Why is it doing that? Okay, seems fine now. Wow, look at all that wasted memory. What is that? No one's put any thought into this stuff. We just waste memory like it grows on trees or something. It grows on expensive Korean trees. Memory's expensive. Why would we so carelessly waste it with this huge orange dick? Yeah, okay, we definitely need to improve this memory graph viewer. This is showing like the memory over the lifetime of the thing, but we need to be able to like click this and like link it back to something. What's being allocated? That's 328 megabytes. We might not be ready for FSDP. There might be so much stupider stuff we're doing. Like nobody's put serious thought into this. There's so much work to do, guys. There's so much work to do. To understand FSDP. Neural networks are getting very large. Ooh. Okay. Even. Gotta be even. Wow. Okay, we also have a profiler, but I feel like there's no way this is gonna work. All right, something. Okay. Also just mega wasteful on these things. So yeah, it's all compute. Oh, and then this stupid disk copy, which is happening every time. Oh, there's so much lower hanging fruit than FSDP. Well, at least with the new multi, they look like they're more like in sync, which is nice. The copies are being overlapped with the compute, so it's good, kind of. You can see the copies there. That copy probably just doesn't even have to happen. Yeah, okay. So before we get to FSDP, there's so much more work to do. We also have a second profiler. Where'd that go? Oh, I see. It's in like an iframe, so you can click back there to get to the UOPS. I mean, Perfetto's slow to load. I want to use like the existing graph layout stuff. Oh, there's so much to do. There's so much to do. There's so much to do. These are each of the kernels. Some trivially sized copies. Maybe we should try something a little bigger. Like a min GPT. Yeah, so I have like a clone of llm.c in here. See if that's going to find the data. Oh, good. It auto-generated that. By the way, every tinybox, so I'm on a tinybox right now, every tinybox has a beautiful RAID array that's very fast. That looks like kind of fast. Is that fast? I don't know. By the way, we're seamlessly on AMD right now. Oh, that means we need the is-even package. Good point. I don't know. Let's try profile equals 1. That's how you profile. So we can see what's going on here. Also see how much slower the profiler makes things. It's almost 0 overhead. It's awesome. If I actually enabled it. I don't think that enables all of Viz. Yeah, so see there's nothing in Viz here, but if I click Profiler, that should work. Cool. Oh, I can use WASD to drive, that's cool. So this is all on one GPU, and that is terrible. Is it even like being jitted or what? Oh, I think that's like the weird testing stuff at the end. I think this is the train job here. Yeah, here we go. All right, so those are the training kernels. This one's insanely slow for some reason. But yeah, that does not put the training on multiple GPUs. I don't know why attention's being implemented manually. Okay, cool. So that has a full implementation of GPT. All right. Should we add a flag to this GPUs that says how much GPUs we're using? We can always run with debug equals 2. See what's actually going on here. So yeah, that's the stuff that's actually running. The batch size is 4? What a pathetic batch size. Why would anyone want their batch size to be 4? It also isn't actually training shit. It's just overfitting on the same batch. Yeah, I mean, we're nowhere near up to that sort of fancy stuff yet. We really haven't even done basics. But that's crazy, though. We're not even running the batch. Synchronize it here. You can also just make this a decorator now. It's a little bit cleaner to read. And like, what takes so long there? Start with debug equals 1. Scheduling, 1.5 seconds. It's not that slow. Okay, let's add a flag to do multiple GPUs. What should I call the flag? GPUs? Or like devices? Let's see if real GPT-2C has something we can just copy, you know? That is one of my life philosophies. Stop thinking, start copying. A lot of people try to think and a lot of people try to be clever. In reality, the other people who you're copying from, if you've heard about it, they've thought about shit way more than you. So just copy their shit. Stop thinking. Everyone, oh, I gotta have my own idea. I gotta be a unique individual. Just copy shit, man. You know who does this right? The Chinese. They know what's up. Ooh, zero redundancy optimizer. Look at this. Oh, they got fancy shit. Oh, zero stage. Oh, that's nice. I think they do it outside of the thing. Here. Oh, DDP. Torch run sets this environment variable. Okay, they're using like torch run. What should the name of our flag be? Stop thinking, start using ChatGPT. Takes forever and gives you a mediocre answer. Unless you pay $200 a month, then it gives you a better answer. Ew. Ew, who's using time.time? Who wrote this garbage? Probably me. You guys know why you shouldn't use time.time, right? No, if you don't know that, just NGMI. PyTorch Lightning, do people still use that? All right, we want to look at DeepSeek's dual pipe. If you use dual pipe, your model is export controlled. Yeah, these are just neat ways to overlap the compute. We're so not there yet. We have so much more to do. Oh, there's so much to do. I mean, really, yeah. So what we'll do, okay. So the way to get at this is that you have a. We should be able to specify this as like a linear programming problem. We know exactly how long each kernel takes, and then like it's just a classic. It's a classic scheduling problem. Num GPUs. Ew. We'll just leave it as GPUs. What do you guys think? Okay. So we're going to have to shard the model in this case. It's just this. All right, now we have to put the data on each. Hopefully it complains. We'll try it with like 3 GPUs and make sure it complains. GPUs 2, let's say. See, we're opening the other device. All buffers must be on the same device. All right, thanks for the insanely useless error. What buffer did I not put on the 2 devices? Tokens? Probably fine. Optimizer should be fine because that's after I move the model. Contiguous, that's good. That's not really right. Whatever, if it's jittered, it'll... It's a little bit annoying, right? You want to synchronize all the devices? I guess synchronize one is fine. All right, so which one did we not put on all the devices? We moved the data. We moved the model. Wow, items. Try values. Yeah, that's better code. TinyGrad, could you give better error messages? Get state dict and get parameters are the same thing. Yeah, wait, why am I even getting state dict? Why don't I just get parameters? Tokens is a thing, but I don't even like use that because I just move the data here. Data itter's not used again. Step. Okay, that's on both. Yeah, it would be really nice if we had a better error message here. Okay, just in the step, it's complaining that they're not all on both devices. Did we miss a parameter or something? We do put the learning rate on both devices, right? Self.device, self.param0 device. Yeah, that's fully right. Alright. Yeah, we can definitely make a better error message for this. Let's see what Viz says. Wait, what? Now they're on the CPU? Who put them on the CPU? What happened to AMD? Don't know. Not gonna ask too many questions. Alright, so all that stuff works until we get to something that doesn't. This is where we copy the data. Looks pretty good, right? Patch size is 4. It's also not happening until we schedule, which is interesting. No. All right, let's try to improve that error message. All buffers must be on the same device. So what are buffs? K.source. If I just print K.source. Start there. Ignore the stupid traceback. Okay, maybe what we actually just want to do is print buffs. I think we're going to get too much more than just doing that. We also need to add better stuff for multi-buffer. We need to add a repr for multi-buffer. This isn't right. No, that's not what I want. I want the actual buffer. How do I print the buffer? That. must be buffer. Okay, well, it's not a buffer. You're Bruce Buffer. You just stand there and watch while other people fight. Ugh, why is this happening too? I've seen this error a bunch of times. What's up with resource temporarily unavailable? Okay, good. Now we just need to add a repr for multi-buffer. It's in device, maybe? Yeah, here it is. So here's buffer. Looks pretty legit, right? We happy with that? Okay, multi-buff. All right, so it has a size of 64. What would have a size of 64 and not be getting a multi-buffer? Oh, there's probably some batch norm garbage or something. Should you use batch norm? Oh, here, it's this stupid tensor ones. I strongly dislike this. What? This is nonsense. Why is that even in there? What? Whatever. That should be free. Because it's never like contiguous or anything. That wasn't it? Well, there's one bug. No. That should be moved. No, that should be fine, actually. Because that should be moved when I look through all the... Let's just get parameters, ignore... No, it doesn't. This doesn't have anything to do with requires grad, right? No. Self-weight device. Okay, that should be right. Those are going to get moved. I mean, this gets to like, you want to like name tensors, right? It would be a lot easier if I could just see the name of what this 64 is. Oh, this tensor A range is wrong? Okay. Fixed. Stupid. Yeah, that would have been a lot easier to fix with a better error message. Okay. It looks like it gets pretty much the same speed on two devices, which is interesting. Still, we improved the error message. That's good. And we added support for sharding, and that should be never wrong. Okay. I mean, our batch size is really tiny. So let's first start by raising the batch size. Mm, 256. That's crazy. 128. That's without any it's got to recompile all the kernels. Failed to allocate. What? Oh, that's a terrible error message. Maybe 128 doesn't fit. Oh, 16? Great. GPUs 2. Will it get faster? I mean, this could all just be bound by something else. Okay, cool. So that's faster. And it looks like it achieves pretty much the same loss. Okay, so we're successfully sharding across 2 GPUs. We can go crazy here and go to 4. We also need to figure out how to parallelize the opening of the devices. I want this to just be like blazingly fast. But George, it's written in Python. You can't make Python blazingly fast. You can. The slowness is just due to your crappy programming. You ever heard of a skill issue? It's a skill issue. That's right. If only I had more skills, this would be blazingly fast. Okay, well, 4 is slower than 2. But that makes sense because our batch size is tiny. I'm sure we can go to a massive batch size and be faster, but 2 GPUs is a good number of GPUs to focus on. All right. Brothman D. Wow, that sounds like that's a Damon. I'll be back. I'll be back, and then we will look into FSDP. Staff engineer at a big company, thinking of quitting to go deep on one technology for a year. What would you pick today? Well, I'd start by saying that you're asking the wrong question. I mean, like, you won't, right? So something I've learned as I've gotten older. When I was young, I remember thinking that I could get all of this stuff done. I remember thinking that like I could get so much done in a day. And the way that I would arrive at this idea was that I would think about, well, that's going to take an hour. I would take a task and I would break that task into subtasks. And then I would estimate how long each one of the subtasks would take. And I'd be like, wow, I could get that done in a day. And this approach just doesn't work. Because A, you're probably wrong about how long the subtasks take. And B, well, there's the 20% of work you talked about, but then there's the other 80%. There's the 80% of debugging or the 80% of whatever. So the way that you finally do get good at estimating how long things are going to take is you pattern match. You look at the closest thing, whatever it is you're trying to do, to what you've done before, and you ask, well, how long did that take? And that's probably going to be a real answer of how long whatever your new thing is going to take is. But then you start to kind of take this philosophy further. You realize that people aren't going to change. The reason that you're not going deep on the one technology is not because you have a job. Quitting your job is not going to change like anything. Why aren't you already focusing on that technology? Why aren't you already obsessed with it? And if you're not, quitting your job isn't going to fix that. One of the biggest misnomers that you'll hear in misnomers, probably the wrong word, but one of the biggest misconceptions people have is that this idea is that you are going to find your passion. People say that, oh, you're going to find your passion or you're going to discover it. Maybe have you tried scuba diving? Maybe scuba diving's your passion. And you may go scuba diving and you may enjoy it, but it's not your passion. Because the person whose passion truly was scuba diving first did it when they were 8 years old, and they've been obsessed with it ever since. And that's just how it works. You don't discover your passion when you're in your 20s or 30s. You were obsessed with this since you were 5. And the reason you don't hear that perspective is because it doesn't sell. Again, the perspective of finding your passion and the reason that that's not normally what people tell you is because that is a less marketable idea. Maybe some of you have watched Over the Garden Wall. I'm not going to give any spoilers for what happens, but there's what happens in the show, and then there's a pretty clear line of what actually happened. But the thing about the what actually happened is you couldn't show it. Because TV shows that look like that, what's the, from my absolute, one of my favorite episodes of television at all time, celebrities, do they know things? What do they know? Let's find out. Mr. Peanut Butter says, but we can't just wrap this up in 30 minutes and give everybody a happy ending. That's just not how life works. And Wanda says, this is network television. This is a sitcom. Figure out how to do it, right? This is network television. It's not a sitcom, but this is network television. That's what we do. And you realize that constrains the type of stories that can be told to a distribution of stories that doesn't match reality. Do you understand what I mean when I... Does everyone here understand what I mean when I say a distribution of stories that doesn't match reality? Do you understand that? Thank you. So when you see advice or things that are given to you, remember that that distribution is not the distribution that matches reality. That distribution is the distribution that will be marketed toward. It's a lot easier to market to people if they believe that they can find their passion in their 20s or 30s. We can sell them that $3,000 scuba diving extravaganza trip. We can sell them scuba diving if they think that there's some chance that it might unlock passion in them. So my real advice to you is, yes, quit your job and start working on tinygrad. And you can say that, oh, George, that's self-serving advice. You just want people to work in tinygrad. But like, what would I pick today? Hello, it's what I do all the time. I am obsessed with this. Neural networks and the training of neural networks. This is. You think back in the day, like what would Turing and von Neumann be doing today? And the answer is this. So yeah, I mean, I believe that, and I believe that tinygrad competes with the competition by being simpler, by focusing on that simplicity, focusing on that beauty of the code, whereas PyTorch and TensorFlow don't focus on that. JAX focuses on simplicity of user experience, and they do a lot of things very well there, but they do not focus on simplicity of code. Read the JAX code. It's extremely convoluted. But they do have this they've definitely simplified the paradigm, which is cool. And there's so much to learn here. This is like something I say about, so this is my second company. My first company was comma.ai, comma.ai. I'm actually in the office right now. That makes self-driving cars. And the thing about self-driving cars is almost everybody I met in the self-driving car space was an idiot. And the companies have all failed. Right? Maybe most notably Cruise Automation. Cruise Automation raised $8 billion, right? Sorry, an idiot's a strong word. I don't think that Kyle Vought's an idiot. I think that his company failed, right? And there has to be some sort of reckoning there. I wonder if he actually did that reckoning. I mean, I saw he raised $150 million for the bot company, so I don't think he did. It's so interesting to watch his Lex Friedman, where their Cruise's original business model was very similar to Comma's, but they gave up on Comma's business model because they decided that it was too hard. Not because it's a bad business model, but because it's too hard. And when you look at the space and when you look at the fact that we're still here today, it says something. I was right about self-driving cars. Look at the players who are still here today and what they've done. And then look at all the ones that failed. So what's so different about that space and this space? I think I really summarize it well in a blog post. If you haven't read this blog post, go read it. I spent 6 years before Comma in the hacking world. I published jailbreaking tools used by tens of millions of people. I wrote an Android root used by 100 million. Software has no cost to replicate, and the internet is a fairly meritocratic place. The tools were good, the internet recognized this, and they got really widespread use. I'd say 95% of people I met in the hacker world were good people, only 5% bad. The business world has this flipped. To get ahead in the hacker world, you need skills. To get ahead in the business world, you need psychopathy. The people in self-driving cars were business people. and they were truly the people like the Silicon Valley VC people. These are bad people. These are psychopaths. I think that it becomes a lot easier to understand when you realize that. You know, you can look at a lot of the things in Silicon Valley and you're like, well, these people can't be that dumb. Right? These people have to understand this. And the truth is they do, and they don't care. They are going to pocket their large amounts of money and screw you. So, you know, it's so nice to be in a different space. It's so nice to be in the neural network space, in the neural network framework space. We're back to 95% of people are good people. I don't even know who I disagree with in this space. Like the people publishing like Jax and MLX and PyTorch and they're like good people. I meet them. They're good people. They're honest. They're thinking through hard problems. They discuss trade-offs. So that's so nice about this. Whereas in self-driving cars, it was delusional idiots. The tech pundits who never cite comma.ai on X when it comes to self-driving cars. Well, again, this comes back to what I was saying before. Believing that robo-taxis are going to exist. And to be fair, I mean, Waymo has made a lot of progress, right? It's not that Waymo has done nothing, and it is deployed as a service. And I think something I underestimated about Waymo, a place where I assumed that I was different from the norm. So Waymo there's two reasons why people might prefer Waymo to an Uber today. One is that the Waymos are just nicer cars, right? They're Jaguar I-Paces. The only reason this works is because Waymo's running at a loss. Waymo is subsidizing that. Uber could also have very nice cars if they were willing to run at a loss, but they're not. Uber's trying to be a profitable business, Waymo isn't. So that's one reason people like Waymo more than Uber. Because the Waymo driving experience is largely worse than Uber. The Waymo's a worse driver. Oh, generative agents. Yeah, well, we'll get there. But the other reason that people seem to prefer Waymo to Uber is that they don't want there to be a driver in the car. They don't like having that interaction. And I don't like having that interaction. I would definitely take a little bit more time. If you tell me that a car is going to take 10, 20% more time, but there's no driver in the car, so sold. So sold on that. But I thought that was just me. I thought that was just like my kind of like, I thought like other people liked other people. But, you know, so if that turns out to be true, the business case for Waymo is actually better than I thought it was. But yeah, no, I mean, I still do think that like Waymo does get shut down because they're not going to be able to compete with Tesla. Tesla has done pretty much everything right. And they're just going to win on unit economics. I don't know if this stuff's interesting, but the way that I should really like write up how what's going to end up happening with the self-driving car space, and it's not even over yet, is the scaling of the self-driving car space does not look like the scaling of Uber and Lyft. Waymo might think that it does, but it doesn't. And here's why. Uber and Lyft are marketplaces. Fundamentally, in order to build a successful marketplace, you need to attract both sides of the marketplace, the buyers and the sellers. And you do this by large marketing campaigns, big bonuses, right? Your user acquisition cost is really high, but that's okay. Because once you've established this entrenched marketplace, it's really, really hard for people to switch. But there's another rollout of these services that doesn't look like this, and that's the scooter services. So in order to scale a self-driving service, in order to scale Uber, you have to get drivers and you have to get riders. In order to scale a scooter service, you just have to get capital and riders. Deploying scooters, you're not attracting the scooters to the marketplace. I don't need incentives to get people to come out and be scooters. No, I need to buy a boatload of scooters from China. And self-driving cars are going to be the exact same way. So I think Tesla does well. I also think the Chinese companies do well. I think fundamentally these companies that can produce EVs at a low cost can come in and dominate the self-driving market. The software will be a commodity. Maybe not on day one, but give it 5 years. Right? There will be a 5-year gap at most, between the first person basically having the software and everybody having the software. You can look at the lag in like open source of LLMs, and the lag is maybe like two years. So yeah, I mean you do a lot of the DD for VC in the generative agent space is disgusting. I mean these people are scammers. There's no more pretense about this anymore. I'm not sure exactly what stops them. Again, a lot of people have not figured it out yet, but they are not. These people have nothing to do with technology. Nothing's going to come out of any of this stuff. Look at crypto. Look at the massive wasteland that was investment into crypto. Nothing came out of it. Because, I mean, what's the best thing crypto can do? We can dive into that, but like the end of the day, you have to produce value. And these VC-backed companies are never going to produce more value than what they raise. But no one's under any illusions that they will, and that's why I say that these people are scammers. The VCs that are investing in these companies do not expect this company will be around for 10 years. They're not even really expecting an acquisition anymore. A common path in a lot of the 2010s era of VC was they would get acquired by a large tech company. But this isn't really even happening that much anymore. What's happening now is that they will just dump their bags on somebody else. Right? There's 3 ways to make money off an investment. Right? One is, well, this company is actually going to become profitable and start to pay some of that profits back to the investors. This is the honorable way to do it. Another is, okay, we'll put something together, we'll get acquired by a larger company. Okay, fine. But the third is, this is never actually going to produce value, we're just early. And that's a Ponzi scheme. You don't need the company to ever produce value or get acquired. You just need to get in at 10 million, and you need to make sure the next guy gets in at 100. And you need to make sure that there is a next guy. And very often the next guy is retail. Or retail is the last guy. Dumping on retail, again, the complete gutting of the middle class. When you look at your average stock trading account owned by an individual, they do way worse than index funds. You can't believe it. I can't believe it. You talk to the average person and they think, they don't understand that the stock market's really totally rigged against them. To be fair, it's not like gambling, right? It's not like gambling in a casino. When you gamble in a casino, the casino has a house edge. So you will lose. Even if you invest in the stock market poorly, the stock market does grow over time. The house edge is negative in the stock market. The house edge is actually going to give you money. But the average individual brokerage account makes way less than if they just put their money in an index fund. So yeah, no, and we can get into the psychology of why, but whatever the psychology is of the individual, that psychology is being fully exploited by people with way more market intelligence. Yeah. So, yeah. Coming back to your question. I mean, you already know my answer, but you're not going to do it because that's not who you are. Prove me wrong. Start submitting pull requests to tinygrad. Or start a similar project. Right? Start contributing to open source software somewhere. But you won't do it. Just know who you are. And that's the real truth. But George, you can't just say that. You have to give people hope. No, you have to sell people hope. I mean, you could say the OG hacker George, and this is like, uh, but the things that I'm telling you are not like, these aren't like, I'm not a conservative, I'm a progressive. These things are not like conservative values that I'm telling you. Like, oh, back in my day, businesses used to make money. Like, no. No, this isn't like that. One of the problems with these sort of bubbles is they don't occur that often. You might only see one or two in your lifetime, and people are really bad. Everyone thinks that this time's going to be different, but it's shocking how little people actually just trust history. I mean, the biggest thing that's going on today is the fiat currency. We aren't in some new era where fiat currency is okay. Fiat currency is as stupid today as it was for the Romans. It's as stupid as it was for the Weimar Republic. It's just as stupid as that. For some reason, though, people think it's different. And they don't have a good reason for thinking it's different. They just don't trust history. They haven't seen a hyperinflation. They haven't seen these bubbles where it goes really badly. Like 2008 was nothing. And then the question is, like it's just not, people don't think like this. People aren't thinking on any sort of serious timescale in any sort of way. And I don't know what to do about this. I don't know. And then, like, there are people who will tell you they're thinking on some serious timescale, and then they'll tell you something about, like, how AI is going to kill us. Those people are interesting, right? Those people are like, they're kind of thinking on a serious timescale, but they're also falling for what looks like really obvious cult behavior. Many cults in the past have predicted the end of the world, and, well, the world's still here. But I'm right this time! Many people have said this bubble is going to go on forever, and then the bubble didn't. So just trust history. We'll let non-subscribers chat for a little bit. Time to buy credit default swaps. Let's go. It's like not even fun anymore because there's nothing to buy with the money. That's a time to lower average IQ. Lower average IQ because we did that. You know, I realized something. Like, I saw a screenshot of old Google Transit, and it looked so good. And then what you realize is, like, the internet, the early internet was like a community of 120, 130 average IQ. Higher average IQ than any country. And that's why it was so nice. That's why the internet was nice. Now all the 90 IQ people with mobile phones showed up, and that's why every interface looks like it's designed for retards. A huge amount of bots. What bots? Where are bots at? Yeah, the internet. And we're just never gonna get that again. The internet. Oh wow, you're like, wow, people are so good. This is what people are like. And now, yeah, you're not gonna find your passion after 20. I mean, no, 20 is still a little bit young, but you're definitely not going to find your passion after 25. The member berries are ripe today. How do I prove pair of adjoint functors? Well, I know what two of those words mean. Why don't I use cursor? What does my portfolio look like? I put it all in BitConnect, and then, well, you know, I had to realize that there were things more important than money. Oh, that's so hilarious. You want to talk about a hilarious cope that you see people in their 30s do? So people in their 30s look around and they realize that they're average. They realize that they're a normie, and not only are they a normie, they're doing worse than their parents. So they need some axis on which to not be average. They need some axis on which to be special. If I can't be richer or more successful than my parents, I will have more of the correct beliefs, or I will be more spiritual than my parents. So I think this is one of the appeals of wokeism to people, but I'm specifically going to talk about something I see in tech, which is these people will go to they'll go to Peru and they'll take ayahuasca. Now, I don't actually think I think that drugs change people physically not all that much. But the problem with these people is, and I think that also psychedelics are a lot more, you're going to get out what you kind of expect to get out of them. These people will go take these large doses of psychedelics, and then they will claim they are enlightened in some way. And I've taken psychedelics. You can kind of like, I'd never take ayahuasca. I'd never take one of those like stupid doses or anything. You kind of see where it comes from. You kind of see how you feel that way. But this is like wireheading to the extreme. And sometimes you meet groups of these people and you're like, wow, like it's just delusion. I see you're always encouraging people to contribute to TinyGrad more than OpenPilot. Oh, I don't know. I mean, I work at TinyGrad. I mean, other people can encourage you to work on OpenPilot. Time was slower in the past. All right. Do you want to discuss the can a neuroscientist understand a microprocessor? Okay, that's definitely time to go back to subscriber only. Maybe we should add the RAM here. Can't fit used, it's too long. Let's see how we're doing on RAM usage. This needs to be faster. Okay, we're using 26 gigabytes of RAM. How many gigabytes do I use with one GPU? Half the gigabytes? Wow, that's not what I was expecting. But yeah, I mean, that must just be all the optimizer space. Okay. Shouldn't do size, we should do n bytes. Okay, the model size is 0.7 gigabytes, yet somehow we're using 14 gigabytes. Wow. Can I set the default float? What happens if I change default float equals half? Does that work? Changes nothing. Okay. So how are we getting to such a crazy amount of gigabytes? The model's tiny. Oh, it probably scales with batch size a bit. I don't know, like how big is it if I do batch size 8? I mean, so things like the optimizer state is not gonna... Oh, actually, you know what? We can just print the optimizer state. Where's the optimizer? Okay. Does this work? I think that's actually going to work. It's kind of... I guess that's a class that it returns that has M's and V's. Yeah, that's probably right. And those are contiguous, so that should be right. Okay, so the optimizer state is double the model. That seems right. And then the gradients are, of course, the exact same size as the model. So this clearly scales with batch size. So it sounds like... Wait, but then something's like really broken about the multi-GPU thing then. I'm choosing 14 gigs. If I go to 2 GPUs, if the same experience with XLA FSDP, that it uses double the gigabytes? Almost double? For the same batch size? No, that don't make sense. Where's all that RAM going? Wait, also, no, something's just like wrong here. Because the JIT is saying it's only that much memory. Why is that using so much memory? Where is that memory going? It's not like the data is a lot of data, right? No, there's definitely not a lot of data. That's very tiny. I'm not even going to print that. It's so small. Why is that happening? Resource blocking I/O error. That just seems like something that has to be like retried. Okay. So also, I mean, I guess, does the optimizer state shrink if I... Oh, interesting. I mean, so that state's going to be per GPU. That still doesn't explain why everything is doubled. So what is it if I do 4 GPUs? We really got to get to the bottom of where memory is being used here. What? That managed to use even more. 61. Something's just broken. No, we got so much work to do. We got so much work to do just like locally. How do you stay skinny? You know, bro, like even though you're a subscriber, that doesn't give you an excuse. We really try to stay on topic on these streams. We're focused on FSDP. So, you know, just stay on topic. Sometimes there's times that are acceptable for off topic, but I don't know why that you thought this was an appropriate time. It wasn't. No. All right, let's like get into RAM usage. Start writing tests for multi-tensor to see if we can figure out how much RAM we're using. I think I'm pretty happy with the changes to this. Oh, I think it also doesn't work if I skip tests. So let's just make sure it works if I skip. Let's just make sure it works with the test. I'm actually not sure that can work. Gonna bitch and whine. Yeah. I'm not 100% sure that works. There might be some like intermediate things that are like broken. You can't run it on like separate devices. Where it has to like recreate stuff. That looks like it works. All right, let's get into... Oh, it is always an ambition to jibe with countrymen. Let's just run it one more time, just because we can. Yo, if you're in the cloud, every time you run it, it's going to cost you money. The cloud's evil. No, the cloud's not evil. People are evil. That's true. Some people are evil. That's true. Most people are good, but some people are evil. That sounds like a... Right? Like we got to fit everything into this like Marvel worldview. This is all locally hosted, by the way. Well, by the way, something you can do. So AWS egress bandwidth cost. Okay, so let's even say you're at the minimum rate. So it's 5 cents per gigabyte on AWS, and we have a 10 gigabit internet connection at this office, right? So let's say that's 1 gigabyte per second. So if you have a file somewhere in an AWS bucket, like you just have like one file, I can keep using all my internet bandwidth to keep requesting that file. And that's going to cost you 5 cents per second. So per minute, per second. Is that right? That's not too bad then. So I cost you 5 cents a second. Oh, no, but per second, minute, hour. Go to the almighty. Ah, yes. So I can charge your company $129,000 per month by just repeatedly curling the file that you hosted on AWS. I'm not even sure that's illegal. But that's why charging for egress is so evil, right? I pay $5,000 a month for the internet connection here. So on my $5,000 a month connection, I can just keep requesting the same resource on your website and charge you $129,000. It's pretty awesome. But yeah, that's why you should be afraid of the cloud. Just know that if you piss someone off enough, they can just do that to you. Let's get into RAM usage. So here we have this great file here called test multi-RAM usage. So I think what we're going to want is, yeah, we can do setup. So first we make a tensor. Oh, yeah. Cost your ISP money. I love that. Love that. Service that should be dirt cheap if it wasn't run by profiteering gluttons. Like, why don't you use cursor for that? Well, yeah, I mean, it would be like a tiny bit faster, maybe, but then I like have to read it, and I don't know. I've never even used Cursor. I used it once. I downloaded it once, and I was like, this is closed source? That's scummy. Why is that being skipped? Not support multi-device? I don't know how I feel about that. Wait, what? Who did that refactor and forgot the parentheses? Okay, that looks pretty good. Great. That should free that, actually. I don't understand why that's not being freed. Yeah, okay, so we can already see a problem. Even though it's already on this device, well, actually, is it? No, it's not on this device. Yeah, the original one's not being freed, even though there's no reference to it. There shouldn't be a reference to it, okay. So it's actually 3. Why isn't that being freed? All right. We're getting at some problem. First one. We just wasting RAM. We just out here wasting RAM. Where's the RAM? Oh, I wasted it. Wait, Eder, is that you? Is tinygrad good for training LLMs? Not really. It does great. Inference is good. Inference is good. For training LLMs, it's kind of pretty good. Pretty good. For training LLMs, you're better off going with PyTorch. Tinygrad's real, like the place where it's really the best in the world at something now is anything that's like inference on anything that's not. I mean, even inference on NVIDIA, we're getting close to being the best. We'll be faster than like Onyx runtime. We'll be faster than Torch unless you put a lot of effort into it. Right? If you just run tinygrad with beam equals 2, it'll be like pretty fast. And yeah, our inference time LLMs are on par with anything else. But yeah, I mean, for LLM training, this like getting this like just generative images. I mean, it works. I did that. Last week I did Flow. You think when LLM inference becomes more like diffusion? Well, first we'll see if it does become. We'll see if LLMs become diffusion. I think there's mixed thoughts on that, but yeah, no, I mean it's still basically the same transformer. that you're running. So much of your diffusion speed comes down to like how well you've done the stuff to minimize the number of steps and all these sort of tricks. Okay, so why isn't that getting freed? Haven't trained one from scratch. Yeah, no, PyTorch is your best bet for that. Thanks for merging your PR yesterday. Which one? Overall, we discouraged the use of AI. Oh, the typo one. Okay. Yeah, I mean, that's on par with almost what I don't merge. To be fair, we discourage the use of AI. And it's not that like you can't use AI to help you, but like sometimes we'll see PRs that are like really and then this person came in and they posted on a Discord. They're like, why did you close my PR? So like, what the hell is this? First of all, right? I never want to see something that looks like this. That is so clear that it's AI. Then you look at the actual changes. So if you read what this does, it doesn't change anything. And I have an idea that the person who submitted this pull request doesn't even understand that it doesn't change anything. Right? Like, look at this change here. That's not a change. They just put that on the next line. Right? Same thing here. Same thing here. They just literally changed white space. Here, they got rid of the wraps and stuff and changed it to this. I don't even think that that's like what? Don't do this. Please don't use AI. Your PR will just be closed and you'll waste everyone's time. Yeah, they're farming GitHub karma. Yeah. No. Well, also these people, this one guy was like bragging about how, I had my AI agent solve a tinygrad bounty. No, you didn't. You had a PR just get closed and waste people's time. So yeah, I mean, if you submit, if we're talking about the typo one, if you submit like a one line, it's a clear typo and simplify, I will merge this. But these aren't the most valuable PRs. It's fine. Net positive, does get merged. But all docs and whitespace managers will be closed unless you're a well-known contributor. No code golf. Speed ups are very questionable. But what we do want are bug fixes with regression tests. These are great. Solve bounties. These are the tinygrad bounties. Features are questionable. Refactors are questionable mostly. If you're not a known contributor, you shouldn't be doing refactors. Look at the change that I made this morning here. Yeah, no, I mean this is all kind of stylistic too. Like I probably wouldn't even merge this. Tests are great. Dead code removal is amazing. All right, so why is the GC not GCing? Why does that not get collected? Why does test 0 del not work? Like that's like a problem, right? So here it runs the kernel to fill the thing with zeros. But then that buffer gets deleted. At least it should. let's dive into buffer here. Maybe a larger. Should we add some debugging to buffer? Seven seems like a good place to put it. We put all this stupid debugging stuff in 7. Oh, Codex is different from Cursor. Yeah, I should try Codex. I think I even pay for the stupid thing. Not really. Here's kind of, I think another thing that people misunderstand about me is that I'm not an early adopter. I don't want to be an early adopter to any of this AI stuff. After people have been using it for like a couple months, if people are still using it after a couple months, I'll try it. Can't believe I actually paid for Claude and tried that. Week. Oh, Bantsman, thank you for gifting subs. You know, for gifting subs, you get to ask a question. If you have a question, you can ask it. A rare question. Yeah, similarly with drugs, but let's not go off topic here. No, I agree. You know, I'm not an anti-vaxxer, but I didn't take the COVID vaccine. I'm not taking that shit. You have some new medical product that's been on the market for 3 months? No, thank you, sir. Yeah, I'll take a Tdap vaccine. I'll take a polio vaccine. I'll take anything that's stood the test of time. Amoxicillin, penicillin. Shit, I'd even trust Prozac more than I'd trust that COVID vaccine. And it's not because there's anything nefarious about the COVID vaccine, people. It's about the only way that any medical stuff actually gets tested is, well, give it 5 years. If people are still taking it in 5 years, yeah, that's probably right. You got a question, Bantsman? All right, why is this not being deallocated? You up sounds like getting stuck somewhere, which is scary. Where are they getting stuck? Oh, there's an LRU on top of this. But no, it's an LRU allocator. That all happens at a lower level. So it's not that. We rely on the Python GC and we do not test it well. Well, okay, so first, let's see if the GC fixes it. Okay, GC don't fix shit. Good. There must be a reference to it somewhere. Where might that buffer be referenced? You can see in a.lazydata. Oh, that doesn't even. What? Oh, no, it's not that. It's this. Okay, there we go. So there's a reference to the buffer, which is fine. That's good. But then when I delete that, there shouldn't be any references to it anymore. All the buffers, I think, are tracked in some, weak graph. This maps you up devices to the... We have GC tests. I just don't know why they don't work. See, like, look at test schedule GC. That works. It's doing basically the same thing I'm doing. Yeah, that's calling deallocate. What's a major thing I changed my mind on? Something I thought I was 100% right on. Yeah, a few gift subs, you can ask a question too. It's still like, I think two things. And they're like kind of related. One is consciousness. I don't think it's real. I used to be like into that kind of stuff. I used to be like into like thinking about like what I am and all that kind of like philosophical stuff. Maybe it's the kind of stuff you just think about in your early 20s that you think's cool. But I remember so vividly going to lunch with this guy. And, he's one of the few people I've met in my life who has like a 10-point higher IQ than me. And we talk about consciousness. And he's like, what do you mean? It's an illusion. And he just says it so definitively. I didn't really believe him at the time. I still wouldn't, I wouldn't do Swamp Man and stuff like that. And then, I kind of just stopped believing in that. And then, like, with that, you kind of stop believing in libertarianism. I mean, I could still believe in, like, some tenets of libertarianism, but this idea that there is some, like, intrinsic consciousness or, in libertarianism, classic liberalism, this idea that there is this, like, almost the idea that there is an underlying person there. And this is upsetting, right? It's upsetting. This isn't a belief that I want to have. I wish the world was different, right? I think that like, when you look at a lot of stuff around how fixed so many of these human things are. You know the big one. I'm not even going to say it, but you know what it is. And you realize what the truth is about this, and it's just kind of upsetting. But there you go. There's my answer. So yeah, kind of the soul, and with it, classic liberalism. So why does that deallocate and this doesn't deallocate? What's going on here? Sure looks the same to me. Yeah, it still exists. Oh, maybe 0. Maybe I actually make this somewhere else? I don't think so. No, it's the same. And what's in the hype chest? Rewards. Respectfully no emote. Oh, I thought it was respectfully no emote, but no, it's a respectfully no emote. I helped my Uncle Jack off a horse. Alright, so why are you not being freed? Why is this not the same test as this? Sure looks like the same test as that. I mean, I guess I do call GC collect. I don't think it matters. Doesn't matter. Be something that's imported? All right. Get reference. Buffer object. Is this a metal problem? No. So reference might not be the right word. Refers. The buffer refers to itself? Wait, what? The only thing I see there is a weak ref. Oh, I see. So that's the buffer dictionary, but that UOP must still exist somehow. Return a list of objects that directly Okay, so what? No. No, that's all the things that refer to this stupid UOP? What? That doesn't make sense. So that's fine. It's just because things are still referring to the UOP, to a.lazydata. There's no way that much stuff refers to the UOP. Just doesn't make sense. Oh, wait, that's none. Okay, so it's not this. It's not that, but then how come if I do buffer, it says the only thing referring to it is the weak ref to the UOP? So nothing refers to the UOP. The UOP is being freed. It's just that this weak key dictionary is not working. I don't even like that I store them like this. I think this like doesn't happen. I think this doesn't happen until I create a new buffer or something, until I interact with the buffer dictionary, which is kind of annoying. I can make global memory an accessor, but no, I don't like that. What? No, doesn't work. What? No, but that's the UOP that got deleted. Oh, that's the buffer UOP. Oh, interesting. Okay. So WA was GC'd. WA was GC'd, but it says just because that's a view. If we actually do .buffer on here, that's not being GC'd. Aha, okay. So what's keeping a pointer to that? No, it's not that, though. It can't just be that, because that's the only... That's a weak ref. I don't get it. The only ref can't be a weak ref. I don't know. Okay. We ordered some handful noodles. They'll be here soon. What's going on? Who knows what's going on? But the only reference to it is that. It's not even a reference to it. Is that the buffer's object? Some dictionary. I have a lot of skepticism about these. That's still 1? How does it even have an LB ref count? Is this interesting at all? Did it have children? Bunch of weak graphs. I know it's going to be something stupid. If all these children are still alive, why aren't they referring to it? Wait, why is there only 1 ref here? That's the big question. I get it if it's being kept alive by other things. List of objects that directly I don't understand this. Okay. The only reference to the buffer UOP is a weak ref. Why is it not collected? Do we have to write our own weak key dictionary? I don't trust this. Yeah, I have a lot of questions about this. Isn't the JIT as well? Oh. Okay, wait, no, that's wrong. That's the buffer. Oh, of course the buffer has a ref. Okay. That was dumb. This is what I want to look at. The buffer UOP. Okay. The buffer UOP has 8 refs. Many of them are a tuple. They're all tuples. Where are these tuples? Oh, they must be sources. Okay, so this just might be as simple as looking at the children, because some of the children are staying alive. Okay. Okay. Big progress, big progress. Let's look at the children. Okay. Kernel. So why are those all being kept alive? The whole kernel graph's being kept alive somewhere. Shouldn't be, though. Where? More stupid UOPs. Okay. The kernel graph is being kept alive somewhere, even after we realize it. We don't like cache any of this stuff, right? I feel like it's going to be in some stupid cache. That changes nothing. Where is that being kept alive? It's not the method cache, right? Parent should be fine to cache. Not even going to get into that. Oh, it's just because it's not a property. Okay. Where are these being cached? Where are these stupid UOPs kept alive? have a test, and it'll pass, and then nobody's going to break it again because the test passes. Tuple. Oh. I mean, I guess what we should do is, like, get to the... root of the children? We want to, like, recursively traverse the children? Until we find ones that have no children? Because they're kept alive by something else, right? That work? Oh, weak graph. Okay, there's 8 that have no children. So what's keeping them alive? Tracked graph rewrite? Oh, it's because I'm running it with Viz. Stupid. Viz keeps all of them around. That was so dumb. I still don't understand why that's not 0, but whatever. Okay, also, that's deallocating. I don't understand why it's used. Okay, well, that was a huge waste of time. I hope everybody enjoyed their huge waste of time. Did everybody enjoy their huge waste of time? How's everyone feeling about that big waste of time? Great. That's the only way to feel. All right, so it was GC'd. Why didn't it subtract the... So it should have subtracted the n bytes. The device definitely doesn't start with disk. So why didn't it subtract the n bytes? Why does it still think there's bytes used? 0. Why is that much used? Something allocating? Cert used is 0. Global counter, global mem. You're welcome, Dippa420. Thank you for subscribing. That's what you get with your subscription. Alright, so I don't get that. Not 0. I don't know. Oh. Wait, what? I'm not even looking at the right thing. I don't even know. What is global mem? Oh, it's just memory accessed. Okay, well, I was just looking at the wrong thing. So, stupid. Okay, test passes. Great. Did everyone have a good time? Good, all the test pass. Oh, we're so test rich now. Great. I don't know. Do we want to keep any of this crap around? No, it was kind of useless. It was actually all a red herring. No one's ever going to use any of it. Great. Now again with viz equals 1. No, viz equals 1 breaks it. It's Quasilin's job. Ugh. Okay, now we can finally get into what we were going to do. After waste big time. We waste big time. Shouldn't just have random ends hanging around. Self.at. Okay. Great. Oh, but see, now I want to use viz. Now I used even more RAMs. N is kind of large. We don't need such a big N. 100. That's a good N. 1,000. That's an even better N. Yeah, what do you guys think? 1,000. 100. That's a good N. Yeah, 100. Yeah. Rushed for an average of 8 1/3 yards per carry. All eyes were on you junior year. All right, so you see clearly what we're doing wrong here. Chrome spokes on your Japanese bike. This one has got to go there. But that's a lot to figure out. Okay, well, I mean, that's the first problem. We're just massively wasting RAM by being dumb. Oh, you know what would actually fix this? There we go. Pretty good, right? So we do a contiguous, it works. It's still stupidly copying everything. We should also probably track the total bytes copied. It's an interesting idea. Global mem is kind of that. Do we increment global mem for copies? Okay, well, at least we have a way to keep going and write more tests. Because we can just put contiguous there. But this is really stupidly copying. Because what you have to do is you have to reorder this view and this copy. So right here, we're making the 100 by 100 tensor, and then we're copying it to both devices, and then we're slicing it. But yeah, when that goes there, it'll work. But that's got to like split that copy. Scheduler crap. I mean, what exactly do we want to test here? We found a major bug with this. This is a major bug. Like, all the sharding is just fake. I mean, it won't be fake as soon as you actually multiply it by something, but I think that never happens. For, like, these things. Like, they just get multiplied, but then the thing stays around. So they don't actually get freed ever. Ugh. I mean, that's what we have to fix before we even can talk about FSDP, right? Like, we're not even like, so much work to do, so much work. So much work. We need people to help. Is this stuff, I don't know. Like, is tinygrad like inaccessible? Like, there used to be more people helping with this. And I guess that's kind of just the trajectory of open source projects, right? As they get not just more complex, but more polished. Like, making progress gets slower. And I want to try to, like, fix that. I want to try to fix that whole issue. I want to figure out how we can still make progress. You also have to know that that's the only child of the copy. But yeah, I mean, this should happen at the buffer. I don't even know how this memory graph works. The buffers don't get freed when viz is happening. The amount of getm viz. Alright, it'll be lunchtime soon. Lunchtime will be a good time. What do I do about that? Does that still keep it around? Yeah, it looks like it does. Okay, fine. Can I actually do, like... Cool, it's just a normal variable. Just doesn't complain about them. It's a funny Python line. I'll zoom in on that one so you guys can all see it. Del bar. We have so much to do before we even get to the pipes. I mean, what year was FSDP? 2023. Oh, that's not... Okay, what year was this stuff? 2020. All right, we're still catching up. Just talk to ChatGPT about it. You know, right as I'm asking that question, I kind of already see it. In fact, you almost want to just like put the whole model in one tensor. Think about that. Think about just like putting all these parameters in one contiguous chunk of memory. Then you could put all these parameters in one contiguous chunk of memory, and the whole optimizer would just be like, or like put the gradients, you know, well, no, but then you couldn't. Yes, you do. Like, is there any advantage to running the optimizer in the middle? You can see this all as like one big sharded thing, right? That doesn't really matter what size these other tensors are. We could even write it that way. We could write it as a big like tensor.cat all the params. Cat the params, cat the grads. At rest, every rank only stores one end. Oh, flattens all weights of a unit into the flat parameter buffer. Yeah, okay, that's exactly what I was kind of talking about. I mean, you can also, yeah, you also like can like do these things as like a partial. Torch Optim Atom does that when fused is true. Interesting. Is this a new parameter? When did this start to exist? Vertical and horizontal fusion? When did Torch add this? There's also a flag called for each. What's for each? Oh, my food is arriving. Yeah, I gotta get my food. I'll be back, boys. Don't do anything I wouldn't do. Oh, was that in 2.0? Interesting. Ah, yes. Okay, well, let me share the food with you. So today we'll be eating this Chinese chicken dish. There's actually some excellent Chinese food in San Diego. There's one part called Convoy Street. It's very like real. All these places don't even have English menus. This is the Shanxi Magic Kitchen. Though it's interesting, it's not like, this is definitely not Americanized Chinese food. But it's also not, I've never seen anything like this in China either. Like just this use of potato here. You don't really see that in China. But I love this dish. It's one of my favorite things to order. I'll let everybody talk since it's eating time. Little or no knowledge of AI or ML and Tiny Guide. Who knows web development? How much was this? $19. Only 26 delivered. This is hand pull noodle chicken or something. And we'll get to the noodles in a minute. Oh, good. They give me napkins too. That's great. I wish I could tilt it down a little more, but you'll just have to. This is the best view we get of the food. You know, it's kind of like those like low quality amateur porn videos, where like the guy just puts the camera on the nightstand. That's one thing I wish I knew. I don't know. There's a noodle out. Who got that? So it kind of like comes together. Like you really got to dig for the noodle. But the noodles are great. I love the chicken. So we start with the potatoes and then we'll get into this chicken. So yeah, this is like it's those like hand pull noodle, you know. They got rid of what? Amateur porn with the thing on the nightstand? Well, it's hard to find on Pornhub, sure. Amateur porn is alive and well and better than ever. You watch even like production porn from like the 90s, like wow, this is what people had. Now like some girl just like has an iPhone and posts some video on Reddit, and it's like better quality than the best porn from the 90s, you know. Technology. Yeah, we're eating food. All right, so it was added in October 28th. I love ChatGPT. O1 was the first LLM I really started using. Before that, I just felt they weren't very good. Like, I like that it spent 1 minute and 46 seconds thinking about what it was going to say to me before it said anything. Thank you. I wish more humans could do that. Imagine humans spent 1 minute and 46 seconds thinking before they just started talking. Ugh. I tried all the other ones, they just weren't very good. Yeah, 3 is my favorite model. It's just better than 1. Horizontal fusion. Launch once per... I don't understand this. Launch once per list of tensors? The old LLMs too, like you had to spend a lot more time on the prompt. Oh, I see. Really? Oh. Oh, but okay, so fuse doesn't mean... I see. Okay, cool. So we should really rewrite the optimizer to just concatenate all the shit together and not use a Python for loop. Actually, that should totally just work. Why do people always like immediately ask questions like any reason you don't use O3 instead of Gemini Pro or Claude 3.0? Like, they're all the same shit. I like this one marginally better, except for Claude. The rest are fine. No, actually, I really don't like Claude and Gemini, but I have different issues with both of them. But who cares? It's like keyboard circle trick. I don't know if I'm still paying the $200. I delete it every once in a while. And then I put it back as soon as I hit a limit. So. When Tiny Grad Hackathon in San Diego? Do people want to go to that? We could do that. We could throw a Tiny Grad Hackathon. The noodles are legit. Yeah, absolutely. And like the spice blend is correct as well. Um, like you'd never find chicken like this in westernized Chinese food, where they just leave you the bone. I guess it's like I said, you got to pull a bone out. You know, that's some China special shit right there. Am I curious? No, definitely not. Try Peruvian food? What's Peruvian food? The reason why you're not using a fork and a knife on it, you go use Claude. Try Indian food? I've had plenty of Indian food in my life. I feel kind of gross after I eat it. Well, it depends. If I get like a chicken tikka masala and like a big naan, yeah, I feel gross. If I get like a what's the like chicken with like the chicken like paneer, you know, the stuff that's like it's like bright red and paneer, is it? I like that. I feel better after I eat that. But yeah, no, the curries are so come on, that's something you guys should know. Tell me about my Indian food. You know the kind of chicken I'm talking about? I thought food in India was like similar. Tandoori chicken, that's what I'm thinking about. Thank you. I don't know. I struggled with food in India. No, it was different. You're right. It's not like something similar happened to like Indian food in India to Chinese food in China as when it came here and like got westernized. I'm holding chopsticks like Claude. Bro, like I live in Asia. If I'm holding chopsticks wrong, I'm going to be holding chopsticks like this for the rest of my life. It was a struggle with food in India. Everything made me kind of like sick to my stomach. Not like really sick. I was also really scared of getting sick. Like normally I'll go to a country and I'll eat whatever street food. If I see locals eating it, I'll eat it. I don't care. But not India. Though to be fair, I actually got norovirus in the UK and it was awful. If I were you, I would eat with a spoon. It's hard for you to eat with chopsticks. Sounds like a skill issue, bro. No, a lot of things in India were a struggle. Yeah, we need most street food in India if it wasn't steaming hot. Yeah, I mean, I did eat some street food. I didn't eat nothing. But I just like I saw so many people eating in these places with his like flies covering meat and I don't know. Also like everything was so polluted. And again, I tried like I don't like go to like touristy places. Like we took a bike and we just tried to like go. And you'd get to like a small town and like the river there is disgusting. Like what is going on here? I've never been to a country that's like this before. To be fair, I haven't traveled in Africa either. But you know, and it's not just a GDP thing. Because like I was in Cambodia and none of this in Cambodia. I mean Cambodia has some like poverty things, but it's not like polluted or trash everywhere or I'm talking about India. No, the UK, I don't know, it was a fluke. The UK had clean air. I was so happy, like landing in London from Hong Kong, and just breathing that fresh. Where's the weirdest places I've been to? Went to Mongolia. I haven't been anywhere that weird though. The Wales countryside? No. Oh, London had clean air. It was nice. Is it Kashmir? I don't really know what that is. Estonian countryside? Isn't the Polish countryside? But it's not that different. Polish countryside, and then as soon as we cross, it's so interesting crossing from Poland to Lithuania, how different the vegetation in Lithuania was. The Hong Kong air is not the best. It's not terrible. Like, it's a lot better than mainland, a lot better than India, a lot better than Dubai. But it's not as good as, like, the UK or America. I don't really think it's Hong Kong's fault. I think it's just pollution from mainland. Sorry. Fog from mainland. What's the approved? I've been to Dubai, yeah. I've been to, like, every major place people go, I've been to. To like 52 countries or something. Come to KSA? What's KSA? Have I been to Jerusalem? No, I'm scared to go to Israel. My sister went. They grilled her at the border. Not my idea of a good time. And I'm not scared of the Palestinians and the terrorism. I'm scared of the IDF grilling me. I'm just like, I don't even have anything wrong, but I don't want to experience that. And like, I respect that they got to do that, but HKR is way nicer than mainland. That's one of the main reasons I couldn't live in mainland. Even just, I still, like, my cough still comes from the 3 days I spent in Shenzhen, and like, it's not far. You can see Hong Kong from Shenzhen. I've been to Macau. Weird. I thought Macau was going to be Vegas, but you show up in the casino, there's no music, they're serving you apple juice and tea, and there's thousands of very serious looking Chinese people playing Baccarat. Like, I thought it was like party. It's like, no, it's like, we're going to go and do gambling. We're very serious about gambling. The bounties are not clear. Well, they are clear to the person who can do them. The last time I gambled? I don't know. Probably last time I was in Vegas, we played like a bit of craps or something. I think Macau really had a downturn during COVID. Kind of sad that I didn't go pre-COVID. Maybe he'll come back. I think it is coming back. But it is clearly not as rich as Hong Kong or even mainland now. You think Xi is not a great leader? Well, we're in America and you can say that. I actually don't agree with you. I would take Xi Jinping over the leadership of America any day. Why? I think that he genuinely cares about the improvement of China. And even if he cares about it for nationalist reasons, egotistical reasons, racist reasons, I don't care. He cares about the improvement of his country. He cares about his country getting better, which is not true, I think, for most American leadership. Trump cares way more than Xi. It's not. I do think Trump cares in a certain way. I think it's like unfortunate that. I mean, he definitely cares. He does it for free, but it's unfortunate that, like, I mean, even the slogan, like, "Make America Great Again," it's like, when was America so great? What are you trying to do? Like the 50s? Like, I wish, yeah. You don't, yeah. I mean, also, like, how is having the Trump crypto meme coin compatible with caring about America, right? You don't see Xi doing that kind of shit. Hu Yaobang? I'm kind of embarrassed to know I couldn't tell you who was between Deng Xiaoping and Xi. I don't know. Let's not talk about this. This is stupid. You can't change it, and AI is going to blow all these vatos away. You want numbers to go up, right? All right. I'm pretty happy with food time. The potato was slightly undercooked. We didn't boil that one enough. I don't take Adderall. I did in the past sometimes. The thing about Adderall is it makes you think you're better at things, doesn't actually make you better at things. And actually just deludes your self-perception mostly. It's pretty dangerous. China has concerns with population collapse too. We'll see how they deal with that. I mean, not on the level of Japan and Korea, but yes. Numbers need to go down on stats.tinygrad.win. Those are bad numbers. New trend of thin phones. I heard the Fold 7 is going to be thin. China to be the first country to set up a base on the moon? I don't know. Let's give Elon power. I think he could beat him. The U.S. is so far ahead in space, but I believe that we can find a way to squander it. Don't worry. I believe that with poor American leadership, we can find a way to squander any leads we have. Oh, they're working on an AI model. The last thing I want is more Apple intelligence in my life. If there's already a base on the moon, we'd see it. You'd probably see that with a telescope if it existed. Could you? I don't actually know. With a telescope on Earth, what resolution can you resolve on the moon? With a telescope on Earth, what resolution could you resolve on the moon? What if it's on the dark side? Who would build a moon base there? How are you going to see the flag? There's a retro reflector that you can like bounce a laser off of. That one I know. I think the Nazis are, despite Kanye claiming that all his homeboys are Nazis, I don't think there's Nazis still operating a sufficiently powerful organization to put a base on the moon. One kilometer? All right, so, I mean, they'd have to have a football field, right? Like, people are obviously going to play football on the moon. So you'd be able to see it if we had a professional telescope. Was the moon landing legit? No, bro, it was fake. I'm talking about American football. Like, never meant. Is the moon real? I don't know. Not sure. You gotta keep an open mind on questions like that. Nah, this stream is done by my diffusion model. Remember that diffusion model we trained last week? I just scaled it up a bit, put all my streams into it, and that's how you got this stream. All right. That'd be crazy. And I mean, yeah, but you haven't trained a diffusion model in tinygrad. The tariffs on Chinese food. This is American-made Chinese food. All right, subscribers. Where were we? No, I don't have anything bad in my ChatGPT history. I'd just rather not show it to you. So, I mean, that's kind of crazy You want to just try? Let's try catting some stuff. We should also push this. Let's focus on beautiful MNIST. So beautiful MNIST is the beautiful. So can we like fuse this? We'd have to like copy them out. No. Sorry I didn't leave you something more amusing. Where's Streamer? I don't know. Where'd he go? So, it's interesting to think about the concatenation of all of these things. Maybe we'll try writing a new optimizer that doesn't do this. So when you look at beautiful MNIST, this is the step. But a lot of these kernels can be removed. Oh, we should also run with, this will be default soon. So it takes 37 milliseconds for a step. Oh, we're copying the whole thing every time too? That's terrible. That's like just kind of a bug, because that's definitely being copied in. It's like intermediate tensors just aren't working anymore. Whatever. Okay, 31 milliseconds. Beam it if you want to. This uses Atom. The problem is I could do this all as one thing. I should definitely probably start by concatenating the grads. Even if each tensor is computed as its own thing. Oh, if I do put in initial, it will do that. All right, cool. So it eventually goes down to 12 milliseconds. That's kind of reasonable. Love dependent typing. Love me some dependent typing. So we still have this t dot detach. Okay, so we're going to need to flatten the tensors. I think we're going to have to do that every time, but that's fine. What do you think? Fused atom? Do we like it? Does it work? Oh, that's not Different book. Oh, that's not right. Fine. It's definitely less kernels. It looks like it's still correct. The real test is to compare it with beam equals 2. So there's a ton more kernels now. So that's 123 kernels. List assignment out of range? What? It's a weird one. "32 milliseconds. 42 milliseconds. Wow, that's fast. Love this. I don't know why I didn't do this before. Right, and now you see how to shard this properly, right? You could just shard the states. I don't think it matters. Wait, is this just like universally faster? I mean, yeah, you have to think that like what was being done there was kind of dumb. I don't know if this is going to work once there's tons of... Like this kernel is going to be upset on metal because it has tons of inputs. Yeah, I mean, I don't even know what's fusing together here. This is just a much cleaner way to write it, I think. Who loves fused atom? Are you gonna be able to get fused atom like automatically? Probably not. I mean, like, sort of. Yeah, for large model parameters, probably not that much faster. That's true. But still, I mean, it makes it really clear how to do FSDP. It also probably makes scheduling faster, which is something I care about. So that's 123 kernels. All right, why doesn't beam work? It's Let's also just name it fuse atom, so it's like fuse A range. List assignment out of range? Weird. Was this like always broken and we just never knew? Lana Lux, I haven't seen you in a while. Welcome. Welcome to everybody who just came in here. Pretty good. How's the game? Did it get released? Nice. Yeah, it's really hard to get things to a final state. tinygrad. So for reference to everyone new, what we work on this stream is called tinygrad. tinygrad is a competitor to PyTorch and JAX. It's a library for neural network training. So like this is an MNIST trainer. We call it Beautiful MNIST because they've worked hard to make the code beautiful. You see that it's similar to PyTorch. You specify your model architecture, comma, batch norm, max pool, and yeah. But this is not in any ways a toy library. I've been working on this for almost 5 years now. And it can train, it's on MLPerf. So this is like the big competition for different ML chips and frameworks. So you see, we're on the new one too, but see the Tiny Corp right here. Those are the times we got training. And most notably, we used tinygrad. Tinygrad is very conscious about how many lines it uses. So tinygrad is 13,070 lines. Now, before you say, well, that's a lot of lines, you would not believe what's in this library. So we don't use any sort of, we wrote our own GPU drivers even. So this is a computer with some AMD GPUs. So you can see I have 6 7900 XTs, the same GPUs used for gaming. We are talking to those GPUs directly. So let's go in here and I can run with debug equals 2. You see that we're actually like initializing, AMD GFX, AMD SDMA. This is actually loading the firmware onto the GPU and then mapping the PCIe directly into the process space. So it's entirely in user space. There's no kernel component to this. Weren't we the first with AMD on MLPerf? Yes, we were. And let's see what else I can show you. So if we look here, this is just a very small MNIST inference. Tinygrad's extremely debuggable. So we have this thing called viz equals 1. It just shows up here in the web browser. And if you ever wondered what actually went into a neural network, well, you can see it here. So this is the graph. It's a random operator. That's a convolution, max pool. And you can see how this gets transformed. These are the kernels. This is actually what runs on the device. This is the memory usage. And then this gets into actually what one of the kernels is. So this is a 5x5 convolution. You can tell it's 5 by 5 here. This is the weight tensor, which has, it's 5 by 5. The channels in is 1, the channels out is 32. And you can tell it's a 5 by 5 because you see there. So instead of specifying things as something like conv2d, we specify things as a multiply and then a reduce. And so first you're doing, you can think of a matrix multiplication, like think of a cube, put two matrices on the side of it, and then think of the dense multiply, kind of like it's n cubed, right? You have the two squares and they're going through, and like you just draw the lines, and at each point you do a multiply, you put the value there, and then you do a sum, and that's the output matrix on the side there. So that's that mul, and that's that reduce. I don't know if that made any sense. This is a ReLU. So you can see these are the shapes in shape tracker notation. Here we're going to convert them into a notation that can actually be run on the device. We're going to do a bunch of speed optimizations, and then this is the code that's actually generated in C. Now, why is that not fusing with that? That's a great question. Why is that not fusing? What broke? Oh, every time I test something, it's like something's broken. No, actually, I think I know what's broken here. I think that can't fuse because of the output size. But so if you want to see it a little bit simpler, we can turn off the optimizations, go back to that same kernel here, and then you can just read the convolution code. See why that's a convolution. I don't know if you've ever done any GPU programming. Well, so PyTorch is not only millions of lines. PyTorch is also using libraries. So tinygrad uses no libraries at all, or at least no Python libraries. Some of the backends use LLVM, but code is behind camera. Oh, well, here's the code here. So this is C code to implement a 5 by 5 convolution. If you want to see it, and maybe, so that's still running on the GPU, but we can run it on the CPU. If I do clang equals 1, or sorry, it's not clang equals 1 anymore, it's just CPU equals 1. So then you'll be able to see it as full CPU code. So we're looping over the channels dimension, width and height dimension, do the 5 by 5 convolution, accumulate an ACC0. That's what you can't see. Accumulate an ACC0. And then store it for each of those. So yeah, this is a complete library, unlike PyTorch, which depends on many, like PyTorch doesn't have code inside. Well, it kind of does now, but PyTorch doesn't need to use its own code for the convolutions. PyTorch will call to something like CUDNN, which just has a convolution operator for you. The problem with doing that is the CU in CUDNN, of course, stands for CUDA. And CUDA only works on NVIDIA. So if you use CUDNN, which PyTorch relies on quite a bit, you can't just trivially target a different architecture, like AMD or Qualcomm or anything like that. So yes, that is what tinygrad is. And hopefully some of you stuck around for that. And what we're working on today is fused optimizers. So I don't know if you've maybe heard of the atom optimizer or maybe stochastic gradient descent. Here's our code in tinygrad implementing those things. The whole thing is just 150 lines. You can read it and fully understand the optimizers. But you see here we're looping over all the different parameters of the neural network. And we can do this faster if we concatenate them all together and then just do the optimizer once. The advantage also to doing it this way is we can then start thinking about sharding these M and V parameters. And I think we could get some really clever automatic stuff here. And this is, so right now this tensor is the full size of all the parameters. And it's also in type, you can specify the D type, specify a lot of that stuff. So yeah, this is stored on each device because this T device would be oh, interesting. I shouldn't do that. I should do self device. So what we're working on debugging right now is why this beam search doesn't work. Something's broken deep down in the shape tracker, or something's getting deduped. Yeah. How does that even work? See if I don't fuse the atom. It works. So this is training an MNIST model to 89% accuracy. You can see it's using metal here, but of course we can also just target it to the CPU, and then it'll find stuff on the CPU. It's searching over what the fastest way to run each compute is. That's what this is. Yeah, I mean, this comes from this absolute tragic hunk of code called kernel. Kernel is mostly just code that should be deleted. Ugh. We'll kill that. But of course you don't have to use beam. You could just not use beam. Why is that still beaming? Oh, because I have a double beam in there. Get rid of beam. And that runs on the CPU. A little slow, but it runs on the CPU. Oh yeah, we have batch stuff in Clang now. No, it's not multi-core. There's single thread. We could do multi-core, but that would involve, like, we'd have to write like a, what you really want to do is implement a GPU style dispatch on CPUs. And yeah, we could do it. We'll get to it. It's not high priority right now. The goal with tinygrad isn't to chase the latest features or to show off, like we're very unlike something like GGML. Right? GGML is saying, and this is a spectrum, right? Engineering most of the time is just about trade-offs. So they've made a different trade-off. They've made a trade-off to target, like, oh, we're actually going to use this to run this one model on this one piece of hardware, and we're going to hyper-optimize one model, one piece of hardware. tinygrad goes for a very different approach and says, what we are going to do is make something that can run any model on any piece of hardware. Now, the downside to doing that is that it's probably going to be slower, at least at first. You had to do parallel equals 0? Well, if you have some way for me to reproduce that issue, I'm happy to look into it. And there we go. We're trained on the CPU, and you can see we're already at 96%. So, yeah, why doesn't this work? Just because I'm passing the same buffer in. So what calls buffs from Lin? It's an engine realize. Yeah, I mean, this is just like it's like a different problem. Why would the buffer be numbered something that's out of range? That doesn't make sense. Well, let's do it without beam and then see which kernel that is. We can also try JIT-beam. JIT-beam only beams the things in the JIT. So maybe that works. Which kernel is it? Nope, same issue. Do we just have nothing that concatenates with itself? So my guess is what this is going to come down to is that we have duplicate buffers. I don't know. We can try maybe debug equals 3 will enlighten us. We don't need JIT-beam. Look at this one. Why does it say there's only 7 args there, but I see 15? View? What? Okay, those are consts. Usually the consts come last, but they're not this now. Yeah, look at that. What's in 10 through what? Okay, that's even more strange. So the const ones aren't real. 1, 2, 3, 4, 5, 6. There's 6 loads. Okay, that's right. Why do they have such strange numbers? How does this one even work? Where are the other numbers going? Oh, they're getting like folded out or something. Yeah, that doesn't work. Okay. Now we just have a different problem. I mean, that works. Okay. Why is that one not in there? I guess there's like one left over. Oh, that's interesting. All right, 12 milliseconds. What if I don't fuse Atom? $12 milliseconds. Okay, it's slightly faster. Like, this is a fun problem. Somebody can go like look into what's failing here. Let me also not. Three branches today. That's pretty good. Oh, everything gets slow because the tests are running. Someone wants to look into that too. Comma's been using tinygrad, and someone posted in the Comma Slack saying that, oh, well, I tried to run the tinygrad unit tests on my computer and Chrome sad-faced. Yeah, that's because it uses RAM and Chrome uses RAM, you know? Who's the big dog around here? Okay, so it's pretty clear how to do FSDP. Just shard that. And you'll want to shard grads and tensors in the same way. Do they have a token? Sounds like the kind of thing that has a token. Guys, if it has a token, it's a scam. You name it. If there's a token involved, it's just a scam. Like, there's no other reason to do a token. People do these mental gymnastics for why their token's different, but in reality, it's a scam. The thing about things with tokens being scams, Sci-Hub has a token. Oh, that's so sad. Oh, that's so sad. Well, I mean, do they know it's a scam, or are they telling you about how the token's going to decentralize science? Or are they just saying, look, it's a scam to make money? Oh, I had higher hope for whatever that girl's name is who runs Sci-Hub. Don't do that shit. Well, don't believe they have a token. All right. Phew. That would be sad. I'd have to reconsider my whole worldview. Does Sci-Hub have a token? No. No. Wait, no. No, they wouldn't do this. No. Sad. Oh, if it's on Solana, it's definitely a scam. Well, oh well. You know what they say? Like at the end of BoJack, it was nice while it lasted. Oh, okay, wait. This is like a separate project. They made a social network for requesting. Oh man, you know, I built one of these in 2004. It was called Academia, and it was the premier homework cheating website on the internet. You could upload answers to assignments and get tokens, and then other people would pay with tokens, but the tokens were just tracked in a MySQL database. Yeah, why do you need cryptocurrency token? I don't know. All right. This seems less scammy than most of them I've seen. Let's look into it. Okay. If What your token is doing is promoting the end of intellectual property. All right. This is one of the more legit tokens I've seen. All right, never mind. This, as far as I can tell, this is not a scam. Wow. Okay, fine. We found one token that wasn't a scam. I mean, it's a scam if you're going to invest in it and get rich, but if you're going to use this to literally just pay for piracy, oh, I love it. Oh, I mean, my hate of tokens and my love of piracy. Oh, my love of piracy wins over my hate of tokens. Nope, we hate tokens. All tokens are a scam except for this one. All right, SD Tiny Grad Hackathon. What dates? Let me see. Well, let's figure out when most of the team's going to be here. Probably be June or July. We'll have applications. Maybe we want to get about 10 people. You'll get your very own tiny box to play on when you show up to the office. No remote crap. In person. Free food. She's a communist? Well, she's fine. Look, I'm pro. I'm more on the side of communist than I am a lot of like. If by communism you mean the destruction of intellectual property, oh, I love it. I love it. Because intellectual property is not real property in the same way cyberbullying is not real bullying, right? So like if you're trying to abolish private property, but by private property you mean intellectual property, then I'm a communist too, you know? She's a Marxist. Well, you know, hey, look, no. I mean, I don't even really know what that means. I'll take an intelligent Marxist over a MAGA chud any day, you know? No, but we have to stop the immigration. They're going to come and they're going to take my job. I'm insecure. Can't you see that? I need to elect a strong man to government to come protect me from foreign people who will work better than me for lower wages. Those people are way worse than Marxists. Let's check in on Sci-Hub. Beautiful. Oh, it's such a nice website too. Like, this is a good quality website, you know? Why can't other websites look like this? Like, let's go to Reddit. Oh my god, it looks like dog shit. Oh, it just looks like dog. Look at that. Look at that. Like, I've seen a pile of dog shit that looks better than this. No. You want to go to the real? We're getting into like cat piss territory now. Oh my god. Oh, Yahoo is asking me. Oh my god. Like, who can use the internet? Oh, this girl sent me this website. Oh my god. Ah! Ah! Oh, we got another pop-up. Oh, up. Everything's moving. I can't take it. AliExpress. Ugh. I've never been to AliExpress's homepage. This looks awful. Ooh, a Ching Da La La motherboard. I want one. I clicked on it and it took me somewhere else. What? Wait, no. I want that motherboard. That's... Alright, we're gonna have to Google this brand. Wow. Wow, is this how like women feel when they see dresses and stuff? An affordable Chinese motherboard for Xeon? Wait. I kind of love this. Do they make motherboards for Epics? Are there other Chinese motherboards? I love this. I know, no, look, don't get me started. I'm not defending the Chinese internet as a paragon of good internet. I can't believe you download these apps and the shit they're covered in. I tried to order a Luckin coffee, the amount of pop-ups you had to go through there. And these motherboards really work? No, but they have authentic guarantee. Come on. They're test qualified, bro. It's a good motherboard. Quality assurance. Okay. Ice Leo, thank you for gifting subs. The motherboard's a bit. Oh, great. Ooh, what's the crystal structure of glycine phosphide? Wow, look, I clicked on it and it actually went to something. This is a great website. Wow, that's a good website. Look, I clicked on something and it went to what it was supposed to. Each rank owns a model replica and processes batch data. Finally, it is already system across the bank. Comparing with DDP, FSDP reduces memory by charting model parameters, gradients, and optimizer states. It makes it feasible to run models that can't be fit. Outside of forward and backward computation, parameters are fully sharded. Before forward and backward, sharded parameters are gathered into unsharded parameters. Inside backwards, local unsharded gradients are reduced scattered into sharded gradients. Oh. Optimize sharded gradients. Yeah, I mean, I think the first thing that we're going to have to do is move our optimizers all to this kind of architecture. It's going to take some work. But, like, it should be fine. And then this assign is where we would move them off the... I believe all optimizers have this kind of architecture. Yeah, I mean, like, actually... You just look at our optimizers and you see that we have this loop in multiple places, and that's like a clear sign that we're doing something wrong. Yeah, okay. The optimizers have to be refactored to be this. And then we have to make sure that works. In theory, TinyGrad could put these together automatically, but I don't think we're going to do that. Well, then also, this cat has to be done every time because of this assign. Yeah. Shard that. Those are clearly stored on other things. Fix that grad thing, and I think we have FSDP at that point. So does it really not use any more? one big gradient all reduced, done with a reduced scatter. Total payload is the same size. Yeah, I mean, you see it's the same thing. That's so cool. Because you still have to move the sum and share the same. Going to full shard also shards the parameters. Meaning you now need a... I still don't exactly understand why there's a copy of the parameters. We just don't have that. And everything kind of works. So there's that. Actually, let's be more careful with where we use T. We don't actually use T till down there. Well, that's fine. But yeah, so what we'd want to do is we'd want to shard. Those can just go to both devices, but yeah, that could stand both devices. But what we'd want to do is we'd want to shard G, M, and V in order to do FSDP. Okay, we ready to try it? I should have done this in Beautiful MNIST multi-GPU. Beautiful MNIST and Beautiful MNIST multi-GPU should really become the same thing. I don't like that it's two different things. Like, it's so easy to do the multi-GPU. Oh, I earned a hype chest. Oh, things are popping up. Why don't I just go to Skeen or AliExpress or whatever that other shit was? Yahoo.com. Oh, let's look at websites that aren't offensive. Oh, beautiful. What a beautiful website. Is GitHub offensive now? That's offensive. I'm so happy that nothing inside GitHub looks like this. Who is this internet for? Like, why did they make the internet for normie idiots? And every website looks like, okay, this one isn't even that bad. But like, all right, let's look at Cloudflare. Is Cloudflare? How's Cloudflare? Too much stuff moving. Right? Look. Got rid of all the moving stuff. I hate moving stuff, okay? Yes, it is oversaturated colors. I'm kind of sorry about the oversaturated colors. We could repo or .cz. Is this porn? Okay, Big Chungus is very large. Ooh, Big Chungus. Okay, it's something. Yeah, Hacker News. They've managed to keep it 100. Like, that's, yeah, I go to this website frequently because it's not scalding to my eyes when I look at it. Oh my god, why is everything moving? Who is this for? Who did this? Oh, nothing moves, okay? We can even downplay the oversaturated green if it bothers you. Right? Like, nothing on tinygrad website is oversaturated. Oversaturate anything. Vercel.com. I don't even know what that is. Why does that have to move? Moni.ai. Oh, hey. Hey. Interesting. When'd you make your website? Wait, you literally ripped my shit off. Heavensgate.com? Can I join? You know what? Like, this was a website that was offensive a long time ago, but it's actually come so far that it's not offensive. Oh, beautiful. Oh, that's a thing. Oh, if I click there, do I get tape? Oh, I love McMaster. Wow, it's been a long time since I've been to this website. I used to go on McMaster website all the time. Ah, tape. Whoa, look at all the tape. Oh, see, this is a tasteful way. Nothing moves until I mouse over it. This is a tasteful way to shove tons of information in. Oh, I just, like, I want some. It's here Monday? Oh, this website's so responsive that I just... Can I check out with Amazon? I have to create a login? Oh, you lost me. You were so close. You were so close. If there's just a way that I could have clicked buy, I would have bought some polyurethane phone mounting tape. Yeah. I'm done with comma.ai. I'm not giving them any more press. You ripped me off, bros. Not in a clever way. Nothing moves. Something moves there. I mean, it's a product page. At least it's like the product just rotating. It's not that offensive. It's not like the whole page is changing. It's a little offensive, though. Something moves. Ugh, that animation's written in JavaScript. Wait, is it? Is it JavaScript or is it CSS? If it's CSS, it's fine. But if it's JavaScript, no. Feels like JavaScript. Oops. Now I'm out of Brave. Rosneft. I mean, it felt like I was going all the way to Russia to load it from some 90 nanometer processor. All right. I think we understand what FSDP is. Cool. And I think we know how to implement it when we're ready. I mean, it's just like, there's no point now without doing all the stuff. There's so much lower hanging fruit for RAM usage than this. But yeah, so we have to move all our optimizers to this fused mode. I mean, it'll be a lot nicer because this is generic code, actually. Like, this is generic code and this is generic code. So, like, this is the only thing that you're actually going to have to specify in this stuff, right? And then you're going to return out and you're going to return that list. And then that's automatically done for you, and that's automatically done for you. And this is a function called with T and G. So we'll structure it like fused step. Right, then that can become part of the generic. That can become part of the generic optimizer. This can become part of the generic optimizer. I wonder what that actually like looks like. Can we visit? CSS prefers reduced motion. No. Prefers more motion. Yes. Well, who doesn't love pop-ups that gray out the entire screen? It's my favorite feature of the internet. Gotta think there's someone out there like that. Wow. That's cool. Look. Like, this is what it looks like now. The optimizer can be expressed as like one little thing. It doesn't have to be like expressed as this super offensive. All right, so that's all the forwards. Why is that not I don't understand. I don't understand why those are all still there. Oh, I don't know. I was just running some... There's some bugs in Viz. Because I want it to just be a view like that. I don't want it to like... I can actually see it. That's nice. Wow, look at that. That's the weight update. That's one of the updates. It's still gonna... Yeah, okay, so it still does individual updates for all of those. Okay, it's doing views into this thing, which is nice, because you could push these views back through here, but why would you? Oh, this is so nice. Oh, fused optimizer. Oh, this is nice. All right, and then we'll get multi-output things, and then multi-output things can output both M and V at the same time. All right, because like right now, like here, this is like M and V, and they're going to be put in separate kernels, but multi-output will let us put them in the same kernel. Wow, what an improvement. Oh, let me just disable that reduce split. Group reduces. Split reduce up. These are all the parameters that can affect behavior in tinygrad. What? Why is that printing so much crap? Oh, they're all the forks are trying to run Viz. Oh, Viz and Beam don't work together. Yo, guys, we need more people to fix all this shit. We got to get people using tinygrad. We got to get tinygrad faster. Oh, this is a huge win. Oh, this is going to be so nice too, because then you don't have to schedule each one of those kernels. Like, I'm trying to think if there's any downside to doing this. I guess would be no. Oh, codec can't. AI sucks. It's less of a scam than tokens, but only a little bit less. Can't believe Sci-Hub made a token. You guys proved me wrong that not all tokens are awful scams. Okay, fine. 98% of tokens are awful scams. If you're making a token social network, okay, you know what? I'll clarify. It's not even always the token necessarily. It's your initial coin offering or whatever euphemistic crap they're calling it now. No. It's an initial coin. Oh, it's just an initial. Oh, it's just a tokenized equity. Blah 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 blah. I hate all these people. Yeah, AI is mostly not a scam. I mean, everyone kind of knows. You can just use ChatGPT. It's like not a scam. All right, so those are the assigns. We're not going to get out of those assigns. This is the backwards pass. Pew, backwards pass. This is the forwards pass. Oh, it's so much more readable too with these fused things. What PyTorch calls vertical fusion, tinygrad's already been doing. But this is horizontal fusion. Yeah. So I think merging this is the first step toward FSDP. Maybe I'll do that this week. It'll be a nice project for the week. And then here's the actual. So that would get sent across, and that would run on all the things. No, wait, why are those separate? Oh no, these are the batch norm updates. Oh, that's interesting. I mean, in theory, we could also like horizontalize those. Oh no, just starting with the optimizer is a good start. But you're right, it's a good question. Whenever you like do a hand optimization, it's always a good question to ask, what would it take to do this automatically? Yeah, I see. So all those ads are going to go in one kernel. This also involves definitely fixing the max limit for metal, fixing buffer limits. So here's the randomness at the beginning, where we choose how to pick our samples. We pick our samples, select our samples, put them through convolution, max pool. I mean, like, that's the intermediate gradient getting computed there, which is interesting. And then, like, these are all the final weight gradients that get computed. We sum across the batch. All right, cool. I'm pretty happy with that. We learned what FSDP was. We know what we're going to have to shard. We found several bugs that need fixing. We realized that we're not quite up to FSDP yet. We're going to have to first implement fused, which seems like actually even a net line win. Every time that we can like use less lines but improve the overall structure of the tinygrad, I'm very happy. This is a massive addition. It's going to be like a massive big plus. But wow, yeah, there was all that like crap that we had to do in the optimizer before. All that crap is just gone, concatenated into one mega tensor. Mega tensor. Those are the views, and that's where you reassign it back. I want to make this like whole graph more readable for MNEST. This is also a good step toward that. You kind of see the structure. Forward pass, part of the backward pass, other part of the backward pass, optimizer, assignments. It's nice the assignments all beautifully line up on that edge now, too. Yeah. But no, I mean, we could try to hack it into something else and, like, hack, but there's no point in doing that until we fix the sharding things and the moving of the copies, and the scheduling of the copies. Oh, scheduling. Oh, scheduling. Got to improve scheduling. All right. I'll submit pull requests for my 3 changes that I made today. Nice 5-hour, 11-minute stream. Do non-subscribers have anything to say? What did you get out of this stream? What are my plans to improve the scheduler? Oh, I don't know about that. We'll get there. Well, I mean, you saw that little thing. It's not like one mega scheduler change. It's like, all right, first we got to figure out how to make that memory test pass. You saw that test that's failing. Figure out how to make that test pass in a good way, and not use all the RAM. That it's faster to run with your legs in parallel? I wouldn't try that. You mean like a bunny hop? Use your legs in parallel? Single instruction, multiple legs? Simul. Mega tensor. But hey, is this like can people follow this? This should be followable for people. Like how we turned this atom, where we loop over the parameters, into this, where we fuse them all together. Like, it's so obvious now when you see it. And then, like, schedule step with grads can become yeah. I'm so self-conscious. This gonna be on YouTube. Couldn't afford a car, so I named my daughter Alexis. Alright, San Diego Hackathon in July. Yeah, we'll see. We'll see when people are around. Do I use an MX3X mouse? There's a reason mouse is a banned term. If I were to invest a lot more time and effort, I could better understand the code base, but this isn't what I hope to do professionally. Ugh, eye roll. Can I listen to the latest Kanye West song on stream? It's very inspiring. Well, I'm glad you found inspiration there, bro. Oh, that one. Oh, people are like, Where's the we'll end the stream with reading comments from our Cozy Diffusion stream. Cozy Diffusion stream was a good stream. This was a good stream. You censor your chat. I don't know. There's a few banned terms. I do censor it. That's right. That's right. This is just like who's the dead guy in Cambodia? Oh, you know, the guy who's a Pol Pot. This is just like Pol Pot's Cambodia. Yeah. People aren't subscribing to you because you're not meeting their demand. You know. This is my favorite Rick and Morty clip.
Yeah. Give me.
You know this clip. This is my favorite Rick and Morty clip of all time, and it's just how I feel.
Yeah. Give me a sec.
These are the forms for the employee health plan?
All right. Yeah. Put them on my. I just got bored. Everybody out.
Yeah. Kanye's song is so catchy. Yeah. Not his first time either. He's been spewing dog whistles for a while. See, this can die with the wokest people, right? Like, this kind of language can die with the wokest people. Like there's like Kanye West, there's the people who censor Kanye West, and then there's these people, right? Like, this is the absolute bottom. Oh, he's been spewing dog whistles. I secretly go in my bunker and jerk off to Hitler, man. Like, what are you thinking? No, like, I believe that people can be adults, you know? Kanye can publish a song, and if you truly believe in liberalism, you can let other people listen to that song and trust that they're capable of thinking critically and coming to their own conclusions. And if you don't trust that, we don't live in a democracy anymore, bro. I thought you liked democracy. Or you just say you like democracy, right? We either live in a democracy where we can trust people with the freedom of the speech, or we don't live in a democracy. And if we're not going to live in a democracy, I would much rather Xi Jinping be my leader than other people, right? So we're going to try to make this democracy thing work? Or are you going to be upset that they're going to cut your Social Security check? Because they are. They're either going to cut it with a controlled demolition or cut it with an uncontrolled demolition. Which would you rather? No, but you can't cut that. No. Well, then we're all going to go bankrupt. Yeah, totally. Just the guy who died 75 years ago. I mean, like, yeah, kind of, right? You know what I mean? Like I get it. Like, this is like the big bad wolf of the current generation. But, like, everybody in history's had one of these. People have no historical perspective, right? Like what Ivan the Terrible? Genghis Khan? Alexander the Great? Like you do understand that you're not new to history. You're not new to humans dying. You're not new to evil people, non-evil people. These stories have been playing out on a tapestry ever since, like, the Bible, man. Ever since God made you, you know? I know about M-Pesa. I mean, I do know about M-Pesa, but I don't think I said it. You were here first. Good for you. Your content is not good enough to pay money for. Hey, man, that is a totally valid... I see your opinion, and I validate your opinion. So, yeah, why not just use ChatGPT? George is a gooner. I don't know about that. Since before the Bible. Yeah, there we go. Why do you use different browsers? Because you gotta stay ahead of the people making the browser shitty. So are we gonna trust people and live in a democracy? Are we gonna believe that we don't have to censor things because we trust our citizenry with words? And that they can listen to words and make up their own mind? Or are we going to say that that's I said it in my stream even before I found out that, like, Trump spurged out about tariffs or whatever. But like that was my biggest problem with the Kamala shit, people. It's like you guys think you know better than me, right? And, like, you think you know better than everybody, and, like, you don't, man. You just don't. Like, I don't agree with the conspiracy people either, but I certainly don't agree with your experts that swore up and down that COVID masks, you got to wear a piece of t-shirt over your face and that's going to somehow prevent the spread of respiratory viruses. Like, no. You're just wrong. Right? Like you never hear the saying the customer's always right. Like, it's not true. Like, the customer's sometimes right. Sometimes the customer's right. Oh, that's another. If you want to, I posted a nice comment on the comma.ai Reddit. About how we're going to add software locks and required monthly subscriptions. We're going to hire a bunch of MBAs, and you're going to see changes around here fast. We're going to have some slick marketing that talks about how comma fits into your unique lifestyle. We'll have phone support that doesn't really know very much but listens to you and makes you feel heard. We'd still have the same 1-year warranty just like Apple, but you'd never interact with an engineer and get a real reply. We'd have a social media manager with no power that replies with phrases like, "Wow, I'm so sorry to hear that." And of course, we'd have a required monthly subscription, right? So that's like, do you guys want the infantilization of society? Do you guys want that? No. We can't let somebody hear a song, because oh no, they might get ideas, man. They might get ideas. And then hopefully you did a good job with your humanities education, educating them so they can evaluate these ideas and think critically. Oh no, you didn't do that? You destroyed the humanities education so that people would be suckers for advertising? Wow. I mean, that's the real gigabrain take here, right? They stripped the colleges of the humanities education, not because they were worried about anybody getting political ideas or anything like that, right? They can't have you thinking critically, because if you think critically, you wouldn't be an adult going to see Marvel movies and purchasing Lord of the Rings Lego sets. We're on Reddit. Come on, you got to do it. There used to be this great subreddit called R Consume Product, and it was just a subreddit of making fun of consumer culture, and it wasn't even partisan, right? It showed back up later, and then it was partisan, and then it's shitty because you have the right-wing 2 minutes hate. Whatever we're hating on this week, is it immigrants? Yeah, it's always immigrants. I don't know, whatever they're hating on, man. But the old Consume Product was this utopia of mocking the consumer, of mocking the 43-year-old overweight man with glasses purchasing a Lord of the Rings Lego set. And that is what we need more of. And I saw a tweet last night that said that soon the world economy is going to be controlled by people who lurked on B between 2005 and 2010. And I'm like, holy shit, that was me. And that means I'm going to get to control the world economy. Singularity is now the anti-work subreddit. Comes full circle, but yeah. Oh, I love that I replied to this guy, and he actually fell for it at first. We're not even gonna call him out, but I just was like, ChatGPT, act like a sycophantic social media manager that makes people feel good but makes no actual difference in what they're saying. And he liked the never mind. We don't gotta just oh man, did you want your life to be emotionally managed? Do you want to live in the pod and eat the bugs? Because I do, but I want it to be a comfortable pod, and I want to make sure that I have root on the pod, and I get a choice of what kind of bugs I'm going to eat, okay? I want demand choices. We're the Pepsi generation, motherfucker, okay? And we demand Pepsi, okay? We demand Pepsi because it fits into our unique lifestyle, okay? Okay, all right, thank you, bye, Happy Saturday. It's a good day. Everybody go out and just accept an ad uncritically today. Look at an ad and don't activate your, I want to skip this. Don't activate your critical thinking. Just look at the ad and be like, I do want to go to the Action Park water park and ride the Cannonball Loop. Thank you for watching today's stream. Bye, everybody.